Jonathan Roux has created many popular and best-selling software courses. In this free course, he will teach you how to use the Kivy library to create games with Python.
You already learned the Python programming language. You have the basics and you are able to create your own programs with Python. But now, what are the next steps? How to improve your skills to the next level and be able to create more powerful applications with a graphical user interface that can run on any platforms: iOS, Android, Mac, Windows. Yes, it's possible to create games, desktop and mobile applications with one single language, Python. And for that, we are going to use the Kivy library. Kivy lets you create games, desktop and mobile applications by sharing the same source code in Python for every platform. That's very powerful. In this tutorial, I will teach you everything you need to know about Kivy step by step. You will learn about the widgets to create user interfaces with buttons, labels, images, and so on. You will use all kinds of layouts for placement strategies and UI that can automatically adapt to every screen sizes, mobile, desktop, and tablets. And you will also learn about the canvas, so you can draw anything you want on the screen: lines, rectangles, circles at 60 frames per second. And finally, you will practice your new skills with a real-world project that we will create from A to Z, the Galaxy project. Galaxy is a perspective game where you need to keep your spaceship on the track. You will learn how to display everything in perspective, how to create an algorithm to generate the land, how to manage screen touch, key press, and how to play sounds. And all of this runs on Mac, Windows, iOS, and Android. So, are you ready? Let's start. Hi, I'm Jonathan. With Python, you can create graphical user interfaces with many different libraries. You have Tkinter, which automatically comes with the installation of Python. It's easy, but not very powerful. You have Qt, which is good to make feature-rich interfaces with many kinds of widgets, but it comes with a commercial license. There is also Pygame, which is more specific to 2D games for Windows and Mac. And finally, there is Kivy. It's based on OpenGL, so the graphics are fast, and it supports all the platforms: Linux, Windows, macOS, Android, iOS, and even Raspberry. That's the library I choose to teach you here because it's easy, versatile, and powerful. This tutorial is made up of two parts. Part 1, you will learn the Kivy library with the lab project. That will be our programming laboratory. Part 2, you will practice your skills with the Galaxy project. In the lab project, you are going to learn how to use the layouts, the widgets, and the canvas. For the Galaxy project, we will progress with 3 versions. Version 1, we will manage the perspective, the movements, and the key press. Version 2, we will generate the land, display the spaceship, and manage the collisions. And version 3, we will finalize the project with a menu, add the game over state, manage the score, display images, and play sounds. But just before, I will show you the installation and setup of Kivy for your project, so that you will have a basic structure that you can always reuse for any project. Also, you can follow this tutorial for PC, Windows, or Mac. To follow this tutorial, you have to know the basics of Python, the variables, the functions, the conditions, the classes, the loops, and also you have to be familiar with a programming environment, like Visual Studio Code or PyCharm. If that's not the case, I invite you to look at my Python beginner tutorial on my YouTube channel, Code with Jonathan. You will find the link in the description. Or you can find also some Python tutorials here on FreeCodeCamp. Okay, let's start with the project creation and installation of Kivy. Let's do it. I am going to show you how to create your project and how to install Kivy. In this course, I will use PyCharm, but I will also show you with Visual Studio Code. And you can follow the same steps on Mac or PC, Windows. If you are on Visual Studio Code, you create a new file, you create a new folder, Kivy the lab, okay? And you will name your file main.py. For every project, you will name your file main.py, okay? With PyCharm, you will click on New Project, then we will call it Kivy the Lab. I advise you to use the virtual environment, but if you are on PC Windows, it's better to use an interpreter directly, because it was some issues with the virtual env. And of course, you need to select a version of Python. Python 3 dot something, minimal version 3.7. You can use 3.7, 3.8, 3.9, 3.10. If you have no interpreter here, you can click on this button, System Interpreter, and then you select your version of Python. Of course, if Python is not installed on your machine, I advise you to go on my YouTube channel, Code with Jonathan. There is a tutorial here that will explain you all the steps to set up your machine and to install Python. Okay, in my case, I will select the virtual environment and I will take a version of Python 3.9. Create. You will get this interface, so in some case it will create a main.py directly. If it's not the case, you can right click here on your project and make a new Python file that you will call main.py. In our case, we are just going to remove the breakpoint here and to remove all the code. Okay, now we are going to install the Kivy library. I will show you first on PyCharm and then on Visual Studio Code. You will click here on Terminal and then you will type Python --version. In my case, it's 3.9.2. That's correct. We need to be sure we use a Python 3 version. And then I will type pip install Kivy, enter. When it's complete, you will type pip list, enter. And then you can see on the list that Kivy has been installed. On Visual Studio Code, you will click here on Terminal, New Terminal, and you will have this interface. Here you will type Python --version, and as you can see, I have a version of Python 2.7 as a default because I am on Mac. On PC Windows, normally you should have installed a Python version 3 something, but if you are on Mac, you will need to type Python 3 --version. Okay, in my case, it displays Python 3.9.2. So take care here, you will need to make sure that Visual Studio Code is using the same version here. On the lower left part here, I need to select a Python 3.9.2. So if I scroll down, you can see I have two versions of Python 3.9.2. I need to use the right one. To do that, I will type which Python 3, and I can see the right path here, python.framework. So this is this version that I will select here. If you are on PC Windows, which does not exist, but you can type where Python to get the path of your Python interpreter. Also in Visual Studio Code, make sure that you have installed the Python extension here, else you will not have the possibility to play the file. Again, I explain you all of that in my Python tutorial on my YouTube channel. Okay, now we are going to write some code that is going to be the basic structure that you will always use with any project with Kivy. I will write it on PyCharm. If you are on Visual Studio Code, you just write the same lines of code. The first thing is to create a class that will be the base class of our application. And we are going to call it the lab. And for every application with Kivy, you need to add app at the end. So it's going to be the lab app. Okay, take care of the uppercase. Then we will inherit from the app class defined in Kivy. I add a semicolon, and this class is going to be empty at the beginning. Okay, you can see that we have to include the app. It's not referenced yet. So for this, either you click here, import Kivy app, but if you are on Visual Studio Code, you will need to write this manually. Take care because this is kivy.app, lowercase, import app with an uppercase. And then we are going to start our empty application. So we will have an empty screen. We will do this so that we can test if our application can initialize properly. So what you will do is that you will take the lab app and you will add some parentheses, .run parentheses. Take care because if you forget the parentheses here and if you write this, it's not going to work. You need to instantiate the class, create an object, and on this object, you will run it. Okay, on Visual Studio Code, you do exactly the same thing. And then you will click on the play. If you don't have the play here at the first time, you will do a right click and click run. Okay, and in my case, I have a black screen. That means everything is working fine. On Visual Studio Code, you do the exact same thing and then you click on the play. And if it says no module name Kivy, that means you forgot to install Kivy. In that case, you need to type pip install. Remember that on the Mac, you need to type pip3 install Kivy. Okay, and then I can click on the play. And I get this black screen, which means everything is okay. At this stage, if you cannot get the black screen and if you get an error that says cannot get a window provider, That means you have a problem with your graphic display. First, you have to know that you cannot start Kivy in a virtual machine. It's not going to work. And sometimes you cannot start Kivy on an external display. And also, if it's not working on Windows, you can upgrade your graphic card drivers. Okay, just before we continue, we are going to define the main interface of our program. And we are going to call it the main widget. You will write class main widget, and it will inherit from the widget class, semicolon, pass, and you need to include kivy.uix.widget.widget. Again, take care here, it's an uppercase. And if you are on Visual Studio Code, you will need to write this line here. We still need to complete a few steps. You are going to create a new file. You will right-click on the name of your project. Don't right-click on VRV, but create your new file here. It's not going to be a Python file, it's a file. And you will call it with the exact same name of your application, the lab. But you don't put app after. You will just put .kv, like Kivy. This file, make sure that this file is in the same directory as the main Python file. This file will be the definition of our graphical interface. It's inside that file that we will explain what we want to display. It's also possible to create our graphical interface directly from the code, but you will see that it's more easy to do it directly from the KV file. And it's also interesting because you will make a separation between your graphical definitions and the logic of your code. Inside this KV file, we are going to explain what is the main interface. And for us, the main interface is this main widget. In the next video, I will show you how to add buttons and labels inside our main widget. But for now, we are going to keep it empty. So I will just take main widget and I will put it here at the beginning of the file and put a semicolon. So this says that the main interface is the main widget. If you start your program, you can still see an empty screen. This is normal because we did not define anything to display. That's all for the base structure of your Kivy project. If you look at some code on internet, you will see some differences. For example, we don't need to call it main widget. And also we can use some layouts directly here instead of the widget. I will show you how to do that later. And also it's not mandatory to use a KV file. You can do everything inside the code. And in that case, you will need to use a function that is called build, and that will return directly the main widget. However, I recommend you to do exactly what we did here and to use a KV file. That's all for the configuration of our project. Let's continue. Everything is okay for the installation of Kivy. At this stage, if you had any issues, first try to search for your error on Google. And if you don't find any information, write a comment just below this video with your exact error message and I will reply you. Okay, just before we continue, let's download the resources pack for this tutorial. You will find the link in the description, or you can directly go to my website, codewithjonathan.net, resources Kivy. In this zip file, you will find some images, sounds, and fonts that we will need later, and also all the source code of the project, so that it can also help if you're getting some errors, because you can compare your source code and mine and spot any differences. Okay, let's move to part number 1, the lab project. I will first tell you more about that project, and then we will go straight into the code. Let's do it. The lab project layout version, this is a beginner project. I'm going to show you a demo of this project right now. First, we will learn how to display some widgets on the screen like buttons and labels, and to change some properties like the colors, the position, and the size. Then we will create some examples on how to organize our content, stacking vertically, stacking horizontally, using some grids and embedding previous content, and also generating items by writing some codes, and to use a scroll view. The objective is to start your practice about Kivy. You will learn about the base structure of a Kivy project, and you will learn how to use the KV files where we can describe our user interface. Then I will show you how to use some basic widgets like the button and the label, and to modify some of their properties. But the most important is to learn how to create interface that can adapt to every screen size, desktop, mobile, and tablet. And that's where we are going to learn and focus mainly about the layouts.
Also, as a good practice, we will use size and position that use only density independent pixels. I will explain you how to do that. The steps: first, create the project and learn about the base structure of Kivy project. Then I will show you how to display some widgets, and then we will focus on placement strategies. Layouts. Concerning the layout, we will progress in 6 steps. Step number 1, box layout. Box layout makes it possible to stack the elements vertically or horizontally. Second step, anchor layout. You can put your content in every corner of the screen or in the center. Third step, grid layout. You organize your content with a number of columns or a number of rows. Step number 4, stack layout. Stack layout is another way of stacking the items, but you will go to a next line and it can also stack items of different size. Step number 5, I will show you how to use the scroll view to be able to scroll when the content is bigger than the window size. We can scroll vertically or horizontally. And step number 6, page layout. I will show you how to reuse some of the previous examples that we have created, and to show them like a book, we will be able to slide from one side to another to display our different layouts. Other layouts exist in Kivy. You have the float layout, the relative layout, and the scatter layout. Concerning the float layout, it's quite close to what we are going to see in the first part by using the widget, so I did not reuse it here in the examples. The relative layout has only an interest when using with the canvas, so we will use that layout in the canvas section of this project. And the scatter layout is very specific to a particular use that is not relevant here, so I did not use it in my list. Are you ready to start with this project? Let's do it. Now we are going to see how to display something in the screen. We have our black screen and now we want to add some content. I will show you how to add a button and also a label. And we are going to add that inside our main widget because our main widget is our main interface. So now I'm going to show you how to define the main widget and how to explain what we want to display inside our widget. To do this, we are going to use this syntax. To explain, this is the definition of our main widget. And inside, I'm going to use the tab. And then I will say we have a button. So you will use button with a B uppercase, semicolon, and inside the button, again, you use the tabs. You can use some properties. For example, text, semicolon, and then we put a value for the text. For example, hello. Take care because in the KV file, we never use the equal sign. We don't write that, we use only the semicolon. Okay, let's start this. You can see that in our window, we have our hello button at the bottom here and we can click on it. We don't have any action on the click button yet. I will show you later how to manage the click of the button. Just a small thing before I comment on the button. Sometimes with PyCharm, you will see that when you start your program, your window will not be selected. It's going to be grayed here and it's not going to be possible to click on the button. If this happens, you just select PyCharm again and select your window again and it will be okay. This is only related to PyCharm and this does not affect the fact that your program is working correctly. Okay, let's go back to the button. You can see the button is displayed on the lower left part of the screen. And even if I resize my window, it's always the case. That's because the default coordinates are 0, 0. 0 for the X and 0 for the Y. When you increase the Y, you will go upper. And when you increase the X, you will go on the right. The default size for the button is 100 pixels and 100 pixels. So let's change that. For example, I can use the size property and I can give 400 pixels width and 200 pixels height. Let's try it. You can see that this time my button is bigger, okay? And we can also move the button by using position. Position, for example, 100 for the X and 200 for the Y. Okay, so we change 100 here and 200 here. Perfect. Let me show you something important. All the dimensions here, the size and the positions are in pixels, but because we are going to work on multiple platforms, computers, mobile phones, tablets, you will see that the screens have different pixels density. And for example, 400 pixels will be displayed very big in some screens or very small in other screens, depending on the pixel density. And we don't want such difference between every display. We want something more homogeneous. So you are not going to use the pixels, but always the DP, density independent pixels. To use the DP, you are going to use this syntax, DP, 400 DP, 200 DP. Okay, and for the position, it's going to be the same, 100 dp, 200 dp. So 400 dp is a lot, and I'm going to show you 40 by 40. The size in dp corresponds to a physical size. For example, if I use 40 by 40 dp for my button, and if I start this, it's going to be the size of a finger. You see this, my window is like deactivated. So if it happens to you, you click on PyCharm window and then you click again on your window, and now it's working, and now I can click on my button. That's what I told you previously. So to go back to the DP, 40 dp by 40 dp is the size of a finger touch. Okay, and it's going to be the exact same size on every device. If we start this on a mobile phone, on a tablet, it's going to be always this same physical size. Okay, let's have a bigger size here, 100 and for example 80. And let's add another button. To do this, I'm just going to copy paste this button, and I will say text hello to. If I restart my program, you can see that we only see hello to button. And that's because it is at the same position and the same size of the first hello button. It's just on top of the previous button. And this is because you first draw this button and then this second button on top. So we need to change the position, for example, position 200 and 300, and let's see what it gives. So now my second button is displayed here. Let's continue. So now we use only the button widget. I'm going to show you how to use a label. For example, I'm going to change this button by a label. The label only displays text on the screen, and it uses the same properties as the button. So we can reuse text property and the size and the position. And if I start this, you can see that now I display a label. The label does not have any interaction with the user. It's just a display on the screen. We can use also some other properties like the color. Color is going to be RGB, red, green, blue, and A alpha. So you need to separate with a comma. And for each component, you're going to give a value between 0 and 100%. So it's going to be between 0 and 1. And if you want to be halfway, it's going to be 0.5. For example, here, I want to display a red color. So I'm going to give 100% red, 0% green, and 0% blue. And for the alpha, I will say that it's 100% visible. If I do this, you can see that my label is displayed in red. I can also apply this property for the button. So I can copy paste this, and let's say that for the button we want something blue. So I will put blue here, red, green, blue, okay? And you can see that the text of my button is blue. For the background of the button, I will show you later in this course how to change the color or how to display an image in the button. That's all for now for the display of these first controls. I will show you later how to use other widgets and also how to use other properties. But now let's focus on the layout, because you can see that if I resize my window, then the control size and positions are not adapted to the window, and that maybe I cannot see everything that I want to display. With the layout, we are going to have a placement strategy to have a display that adapts to every screen size. Let's start with the layout. First, I will show you how to use a box layout, and I will show you how to use it by writing the code in Python and also by using the KV file, so you will see the two syntax. Let's go back to the project. Previously, we have created our main widget. It's our main interface here, and we have displayed a button and a label. So now we are going to create a new class that is going to be our box layout example, which is not a widget, but it's a box layout. Okay, and I can write pass for now. We need to import box layout in Kivy UIX box layout import box layout. Okay, how can I change my main interface? If I start my program, I can still see my button and my label coming from the main widget. So I need to replace my main interface by the box layout example. The main interface can be either a widget or either a layout. If I restart, this time I have an empty screen. So now we are going to add some buttons inside our box layout. I will first show you how to do this with the code and then with the KV file. Usually we only use the KV file, but here I want to show you the two syntax, and you will see that in some case it's useful because later with the stack layout, for example, I will show you how to add 100 buttons and we will use a loop inside the code. So for some specific case, it's useful to know the syntax in the code. First, let's create the init function. Def init, our constructor. Take care because with KV, the constructor takes also another argument, ** key w args. We are not going to use this argument, but it is for the internal working of KV. So it's like this. When you use the super.init and you also pass ** kw args. Okay. Here in the init, I will create a first button. For example, I can use the b1 variable that is going to be a button, and button, we need to import it in KV UIX button. So this line. Also, I can pass some properties to my button. I can pass them directly in the constructor of the button. For example, text equal a. You remember previously that we created button in the KV file this way. We use a text property, but we use a semicolon to give the value. Here in the code, we use the equal sign. The names of the widgets and the name of the properties are the same with the KV file. Okay, so let's create also a second button, button number 2 with the text B. How can I add these buttons inside my layout? So myself, self, this class is a box layout. So we can do self.addWidget. I want to add a widget inside my layout. I add the button 1 and also I can add the button 2. Let's restart our program and see what it gives. You can see we have our two buttons, button A and button B, and they are very big. That's because in fact the layout will use all the space of the window. Because that's our main interface here, it will take all the window space. The box layout is going to stack the different elements. First we gave the button 1 with the A, and then we gave the button B. So it's going to stack the different elements horizontally as a default behavior, but we can also change the orientation. I will show you how to do that. For example, if I add a third button, button C, that is the number 3, okay, you can see that this next button has been stacked on the right, and you can also see that if I resize my window, everything is adapted correctly. Also, as a default for the size of the different buttons, the size will be equal between all the buttons, but we will see how to change that later. Also, the order of the add widget is important. For example, if I do add widget at the end, you will see that the button A is on the right, because first I added button B, then the C, and then the A. Okay, let's go back to this configuration, and I'm going to show you how to use the orientation property. If I want to change the orientation of my box layout, I can do a self.orientation. As a default, it's horizontal, but if I put vertical, you can see that now I'm stacking vertically my different elements. Okay, let's comment all this code and let's do the equivalent of this inside the KV file. So I will comment using this syntax, okay? And because I have removed all the code, I need to put pass to say that it's normal that we don't have any code here. Okay, so now if I restart, I have an empty screen. In the KV file, how can I add buttons to my box layout example? I'm going to copy this and I'm going to define my box layout example. And I will say that inside, I have a button, button A, okay? If I restart, you can see we have one button taking all the screen. Then I can add button B and button C, and you can see it stacking my 3 buttons, okay? And I can also use the orientation property, orientation to vertical if I want to stack vertically, okay? So here we only used buttons in the layout, but we can use also other widgets. For example, I can use label here instead. I can use any widget in my layout, but I will mostly use the button because it has a background and we can really see where it is located. Also, it's possible to embed other layouts inside the layout. Instead of putting a button B here, I can put another box layout, or I can put another kind of layout here. We will do that in the next lecture. Also, how can I resize a button? You can see that the layout is taking care of the position of the elements and of the size of the elements. But can I change that? Previously, we saw how to use the size, for example. So if I say that my button A has a size of 40 dp width and 40 dp height, is it going to work? Let's try. And you can see that it's not working at all. It totally ignored this property. It was working in the widget. In the widget, we could use the size and the pose properties and it was working fine. That's because a widget is not taking care of the position and the size of the element. The layout does. So it will, as a default, ignore pose and size properties. But you may say, yes, but we still want to control the size. For example, we want this button to be smaller than the other button, and we may want to change also its position. We can do that, and that's what we are going to do in the next lecture. Previously, we saw how to use a box layout by adding some widget inside it, and you also learned that the layout is responsible for the position and the size of the different widgets. And also, we saw that we could not use the size property. It was not working inside the layout because the layout is controlling the size. Here, I'm going to show you how to use new properties so we can control the size and the position of the elements inside a layout. And for this, we are not going to use size and position, but we are going to use size hint. First, you can see that I can use the hash sign to do some comments in the KV file. Size hint is going to be a proportion. For example, I'm going to give 80% for the width and 50% for the height. So what do we have? You can see that for my A button, I get 80% of the original width and I get also 50% compared to the other controls. So the percentage is a proportion with the other controls. B has a height that is twice the height of A. As a default, you will have 1 and 1. If I go back to 1 and 1, I get the normal behavior. And for example, let's say that I'm going to get only 50% height, like I just did previously, okay? And now I'm going to say that B will have twice the height. And you can see that now B is twice the height of C. Height of C is 1, height of B is 2, and height of A is 0.5. These sizes are proportions, and you can see that the proportions are kept if I resize the window. Is it possible to use fixed value for the size? You can do that, but you need to say you go in manual mode. That means you say to the layout, you don't want him to manage the size. And to do this, you're going to use none. So I'm going to put none for the width and for the height. And that way I can use the size property. It's going to take it into account now. If I restart, you can see my button is 40 by 40. Or for example, I can use 160, for example. And you can see that the size is fixed. For example, if I resize the window, it's not changing the size. Also, I want to show you that we can write this line a different way, and I will comment it. Okay, if I restart my program, I will have the default size 100 per 100. Okay, I can specify separately the width and the height. I can write width 100 dp, and I can write the height 60 dp. Okay, let's try it. And you can see I get the size that we get previously. But now let's say I want to have 100% width and only have a fixed height. So I can mix between the two. I will keep my fixed height of 60 dp, but for the width, I will keep 100%. Okay, let's try it. You can see I have 100% width and I have fixed height. Now I'm going to show you that we can also change the position. For example, if I put a width of 50%, you can see that my button is displayed on the left. How can I move it to the right? I can use pose hint. Pose hint is also a percentage, but it's going to be a different syntax. It's a dictionary. You will use some components, X, center X, and right for the horizontal, and Y, center Y, and top for the vertical. For horizontal or vertical, you need to pick only one. You cannot specify X and also the right at the same time. And for the vertical, you can also pick only one of the three. In my case, I want to control the horizontal position. For these components, you need to give a percentage between 0 and 100. It's going to be a value between 0 and 1. For example, if I use X and I say X is equal to 0. Then my button is displayed on the left, like we have previously, because the X is the left part of the button and we say it is equal to 0. Now I say that the X is, for example, 10%. You can see that my button moved to 10% of the width of the window. Now I can move to 50%. Now my button is on the right. Because the width of my button is 50% and because I gave the position of the X to be the center of the window, 50%, the button is displayed here. If I give 75%, for example, you can see my button begins to be drawn at 75% and it's a little bit out of the window. And of course, if I give 100%, the button is totally out of the window because the left part of the button is just here at 100%. The same way I can use right, and right is not the left part of the button, but the right part of the button. And if I give 100% for the right part, my button is displayed here because the right part is here, it's at 100%. And if I give it to 50%, you can see my button is here because the right part is at 50% of the screen. Okay, I can use also center X to 50%. Now the button is centered because the center X is the center of the button and we say that the center of the button is at 50% of the window. And it's going to work the same way for the vertical part. So for example, if I stack horizontally, I can just comment this or I can write horizontal. Okay, I will remove this property and I will just comment everything here. So we get, for example, just 50% and 50%. Okay, we have something like this. And I'm going to say I want to draw my button at the top of the window. I can use post hint and put the top to 1. So the top of my button is at the top of the window, 100%. I can also use center Y equal 0.5, for example. Okay, so it's the same logic for the vertical part. That's all concerning the size hint and the post hint. Remember that you need to use these properties to control the position and the size inside the layout. And if you want to use a fixed size, you use the none value and then you can use size property. Let's continue on the project.
You will see that the KV syntax is a good way to build up your interface very quickly. And it's also possible to create widgets and layouts directly from the code. I will show you that in a bit later. You might ask me, but what can we do with KV? Is it only for games or can we make a full application? And also, is it possible to customize all the interface? Yes, I will show you a bit later how to customize the colors, the fonts, and the styles of any widget. But let me show you first some of the projects that I did with KV. I already told you about the Galaxy project that we will do together in this tutorial. It mainly uses the canvas for drawing the game and some layouts and widgets for the menu. Another project that I created is Mr. Beat. It's a software beatbox that uses real-time audio so that you can play any rhythms with any sounds that you want. This project is from my Python full course. If you are interested, you can find the link in the description and it will also appear here. It uses more widgets and more layouts. Also, the interface is totally styled and polished. We have this LCD effect here. You can light the buttons. It also uses a scroll view for the tracks, and it perfectly adapts to any screen sizes. The UI is made from a combination of KV syntax and Python code. It's a good project if you want to go a step further with the KV library. Also, I have published the Galaxy and Mr. Beat project on the iOS and Android store, so you can download them and try them right now. Okay, let me show you a last project, the Pizza project. It looks more simple, but it is more focused on the data management. The pizza menu that you see comes from a web server developed with Django. So the app is not static. It will display the updated data if you add a new pizza or if you change the price of a pizza, for example. The complete project, Django server plus the KV app, is also part of my full Python course. Okay, let's go back to our code. I will show you how to combine multiple layouts.
I am going to show you how to embed a layout inside a layout. For example, here we are going to replace the B button with a box layout containing 4 buttons stacked vertically. How we can do that? You remember that our main layout here is stacking 3 elements, button A, button B, and label C. Button B, we want to replace it. And we are going to stack a box layout here instead. Inside this box layout, we are going to put a button B1, a button B2, B3, and B4. And we are going to stack them vertically. So I'm going to use orientation in this box layout to vertical. If I start it, you can see I have my A button first, then I stack this box layout containing 4 buttons, and then I stack my C label. For this box layout, it's only stacking 3 elements: this button, this box layout, and this label. And inside this box layout, we stack our different elements. Here I have used a box layout inside a box layout, but of course you can mix and use different kinds of layout. And also you can embed at different levels. Inside this box layout, I can also put another layout inside and inside. So you can have multiple levels of embedding. One last thing I want to show you is that we can use a spacing property to space the different items. For example, here for the box layout, I can type spacing and give 10 dp. So let's see what it gives. And you can see I have some space between my different elements. That's all for the embedding of the layout. Let's continue. We have completed the first step with the box layout and we move to the second step, onshore layout. So we are going to create a new class that we are going to call onshore layout example that comes from an onshore layout, and you will need to import it. Import KiwiUIX onshore layout. Okay, and I will write pass. Then I will go back to my KV file and I will say that it's going to be the main interface. Of course, if I restart now, I don't have anything in my window. And of course, we are not losing what we did previously. If I want to see my main widget, I can just replace my main interface here and I can see the previous examples that we did previously. Okay, and later in this course, I will show you how to create a menu with multiple screens, and we will be able to navigate inside the application to all our different examples. But for now, we just do it manually. Okay, I'm going to start on the onshore layout. Let's define it. Inside it, I'm going to put a button with a text that is A. Okay, let's try it. You can see that my onshore layout took all the space. That will be the case every time for the layouts. And inside it, I put a button that also took all the space. So it's not interesting here because I want to change the position of that button inside the screen. So I will need to give a size to this A button. How can I do that? I will need to use size hint. And I will say I give 10% width and 10% height. Okay, let's try it. You see that as a default, the button is at the center of the layout. Now I'm going to show you new properties that we are going to use only for the onshore layout. It's onshore X and onshore Y. And these properties can get different values. For example, right, left, and center for the X, and bottom, top, center for the Y. As a default, it's center and center. So let's say that for the X, for example, I give right, and that I don't define the onshore Y. What is it going to give? You can see that now my button is on the right, and as a default, we are still in the center of the Y. Take care, because the onshore layout takes all the space, and this just defines where he will place the child elements, the widget we put inside. But of course, if we use two buttons, for example, button A and button B, they are going to occupy the same space. It's no stacking here. It's not like a box layout. The behavior of this layout is different. So button B is just above the button A. You can see that if I use 2 and 2 here, my button A is just below, okay? But for now, let's just go back to the previous positions. So I'm just going to comment the button B. Okay, so my button A is on the right center of the screen. How can I display it to the top left corner? For example, in the X, I will use left, and then I will activate onshore Y, and I will give top. Okay, so it's top left. Good. Okay, I can use, for example, the bottom here and the center for the X. bottom center. Okay, so let's keep, for example, the top and center horizontally, this one. So I previously showed you that the different elements are not stacked. So how can I display two buttons? Then I can stack my two buttons in a box layout. Okay, and this box layout is going to be displayed at the top center. Of course, I need to give a size to my box layout. So I'm going to give size hint to this box layout and to remove size hint in the buttons. Okay, let's try that. You see, I have my box layout taking 20% and 20% of the screen size. And inside it, I have my two buttons. That's all that I wanted to show you for the onshore layout. We have completed the step 2 onshore layout and we move to the grid layout. With the grid layout, you can organize content with columns and rows. So let's create our new example, grid layout example that comes from a grid layout. Okay, so again, you will need to import it, import KiwiUI-X grid layout. Okay, so now let's change the main interface with the grid layout and let's define our grid layout example. First, I want to show you something new. We are not obliged to do this. We did this to explain that our grid layout example is a grid layout and we need that in the KV file, else he will not know about our grid layout example. But we can use a small shortcut. If we don't want to use the code in Python, and that's the case here because we will keep it with path, we can just comment that and give the parent class directly here in the definition by using the @ sign and put the parent class directly. That's exactly the same. So this time we don't need to use that. And of course we could do that with our other example previously, except with the box layout example, because we wanted to use some code here. So finally, if you change your mind and if you want to implement some code, you will need to revert and to remove that and to uncomment this code and write your code here. But in this case, we will keep it like this. Grid layout. Let's add some content, button, text, A, and we are going to add a few buttons, B and C. Okay, if I start like this, it's not really working. You can see that the buttons are displayed here because this layout needs two mandatory properties. It's rows, number of rows, or number of columns. You must specify one of these two properties. For example, we say that we have two columns. In that case, I have A, B, and then C. We have two columns. Of course, if I say only one column, it's going to behave like a box layout. We have only one column. And if I say we have three columns, it's also going to be the same as a box layout, except that we stack horizontally. So I'm going to put more buttons inside, D, E, and F. Okay, I keep the three columns, and in that case, I get a grid like this. And I can also use the rows. It's going to work the same way. So I can use rows and say, for example, we have two rows and I'm going to get this result. Okay, that's fine. Now let's say that we want to change the size of this first column. How can I do that? I can resize the A button with the size hint, and I'm going to give 50% horizontally and 100 vertically. If I restart, you see that it's not working because the D button still have a 100%. So the column will still use 100%. But if I copy this to the D button, then because I have the A and the D button to 50%, the column can resize to 50%. So it's still a proportion, but we can have a fixed value. If I use none instead, and if I use a width, for example, 60 dp, and I copy paste that on the D button, let's try it. You can see that this time it's a fixed value on the left. The last thing I want to show you is that again, we can embed a layout inside the grid layout. And for example, we are going to replace the B button. So we already know that we can replace that by a box layout, for example. But we can do even better than that. If I go back to my previous examples, and for example, if I get the box layout example is also a box layout. So I can pick it directly and put it in my grid layout instead of the button B. I will put my box layout example. And if I restart this, you can see that in this cell, I have my box layout example, stacking the A button, this second box layout and the C label, and this second box layout that stacks the elements vertically. So you can see that this is very easy and very powerful. That's all that I wanted to show you with the grid layout. Let's continue on the project. We have completed the third step on the grid layout and we move on to the stack layout. I will create my new stack layout example, and this time I will also create it in the code because we are going to use a KV file, but also we are going to write some code. So I will do stack layout from stack layout, and of course you need to import it. Okay, then I will change my main interface and I will define my stack layout example. The stack layout is stacking the elements, but not the same way as the box layout. The box layout is only in one line, and it will make all the elements fit in this one line or one row. But the stack layout will stack the items on multiple lines, and you need to give the size of each item, and each item can have a different size. And also, I will show you how to change the orientation. So let's start by putting a button, text, and it's going to be A button. Okay, so if I start, you can see that here I have an error. And why do I have an error? Can you see? It says it cannot parse this line because you should never use uppercase on properties. So it's text with a small t. Okay, let's restart. You can see that my button is taking all the space because the stack layout does not manage the size of the items. So we need to specify a size with size hint. And let's say that this button will take only 20% horizontally and vertically. Let's try it. So I have my A button at the top left corner, and we are going to add some more buttons. B and C, B, C. You can see it's stacking the elements this way, and if I resize the window, the buttons are always 20% of the size of the window. So what happens if I add 3 more buttons? D, E, and F. You can see he was able to stack 5 buttons of 20% because it makes 100%, and then he went to the next line. Perfect. So now let's continue and let's add some more buttons, but I want to add them with the code because, for example, I want to add 10 buttons or 100 buttons. So we are going to use a loop. So I will keep all my buttons here in the KV file, but I will also begin to write some code here. Def init with also the ** kw args, and you have to call super init by passing the kw args. Okay, this is the basic structure for the constructor. Then I can begin to write my code, how to create a button and to add it in my stack layout. We saw that previously. I can create a button B, button, and I can give some properties here. So text, for example, it's going to be Z, and I want to add it in my layout, so I can do self.addWidget and I add this B button. If I start that, you can see that the Z button is taking all the space because as a default, he will use a size hint of 1 and 1. So we need to change that, and I can use a comma and do size hint equal to a tuple that is 20% and 20%. Let's try again. What's interesting here is that you can see that the Z button was the first one added in the layout. Then I had the A, B, C, D, and that's because the init is called at first. So first you will do that, and after he will do what is in the KV file, okay? So just to make it more simple here, I will delete what I have in the KV file, and I will keep only my Z button. Okay, now I want to create multiple buttons, so I will use a loop. I will loop here for I in range. Let's say we want to create 10 buttons, 0 to 10. And inside my loop, for each time we loop, we will create a button and we will add it in the layout. Of course, for the text, I want to change and I want to display the value of I. And because I don't want to start with 0, I'm going to display I plus 1 to start from 1. So let's try again. You can see I have 10 buttons and I can resize my window. Perfect. Now our buttons use 20% width and 20% height. What happens if I use a fixed value for the size? I'm going to do that. So I'm going to put none and none for the size hint, and I'm going to give a size property equal to a tuple, and it's going to be, for example, 100 dp. In the code, you need to use dp parenthesis 100, and you need to import that. Import from kivy.metrics, okay? Then I will use a comma for the height and use dp of 100. Okay, let's try it. I restart my program and I have my 10 buttons, but if I resize the window, you can see that the elements are stacked differently because it's a fixed size of the elements. Actually, I don't need to stack elements of the same size. And for example, if I change the size here, and let's say we use a size variable that is going to be dp of 100 plus, we're going to use the value of I multiplied by 10, for example. So we have different size for our buttons. So I'm going to change that here. And you will see that every button has a different size, and we have something like this. Okay, anyway, let's go back to a fixed size. So I'm going to put back size equal dp 100. Size is not the property here, it's just a local variable, okay? I can use any name for this variable. So I want to show you a few more things. The orientation. You can see that we begin to stack from the left to the right and from the top to the bottom, but we can change that behavior with orientation property. So I can use the orientation property from the code directly or from the KV file on my stack layout. I will start with the KV file, orientation. Orientation is not only horizontal or vertical for the stack layout. It's a little bit more complex than that. You can select to stack from left to right and also from top to bottom. And you are going to give a string that is a contraction of that is left to right and top to bottom. This is the default orientation. But if I want to stack from right to left, I can change that, and it's going to stack from right to left and top to bottom, okay? If I change here to bottom to top, you can see that it's stacking from right to left and from bottom to top. And of course, I can do the last one, from left to right and from bottom to top. Left to right and bottom to top. Okay, and it's also possible to use this in the code, so I'm going to show you the equivalent of that. You will do here in your init self.orientation equal, and you put the same value that we did previously. Okay, next thing I want to show you is that we can use a padding value. A padding is an internal margin, so we can use padding, and you will give 4 values. The top padding 20 dp, the left padding 20 dp, then the top padding 40 dp is going to be a clockwise from left, top, right, bottom. Okay, but usually we put the same values for the different area. So I'm going to put 20 dp all around, and we are going to try that. Now you can see this padding effect, this internal margin. Okay, so I'm going to remove it, and I'm going to show you a last thing. We saw previously the spacing with the box layout to put some space between the different elements, and I can give a spacing horizontally and vertically. For example, 20 dp horizontally and 20 dp vertically. Okay, let's try it, and you can see I have a margin between all my different elements. Okay, one last thing. For example, I will go back to the default orientation. So I will comment that, and I will also comment the spacing. So we go back to our 10 buttons like this. And what happens if I decide to put 100 buttons? Let's try it. You can see I don't have enough space in my window. I can expand the window to display more items, but I cannot display the 100 items. To solve that, we are going to use what we call a scroll view that will make the possibility to scroll in the window. And that's what we are going to do in the next lecture. We have completed the step number 4 with the stack layout, and now we move to the scroll view. Previously, we have created a stack layout, and we have 100 items that we cannot display in the window. So we are going to add a scroll view so we are able to scroll and see all the items. I will go to the KV file and I'm going to create my scroll view example that comes from a scroll view. Okay, inside the scroll view, I'm going to put my stack layout example. You can see that scroll view does not have a name of layout. That's because it's a bit different because it can take only one child. In our case, the child is stack layout example. So let's move to this interface scroll view example and restart our program. We can still see our stack layout, but we can still not scroll. And that's because we need to explain to the scroll view what is the size of the content. So the scroll view can compute how much it has to scroll. How can we give the size of the content? We need to give a size hint to our stack layout example. As a default, it has the same size of the window. So the scroll view thinks that the content is the size of the window. So it does not scroll. So we are going to change that. And here we want to scroll vertically only. So for horizontal, I will keep 100%. And for the vertical, I'm going to say none and I'm going to give a value. For example, I can give a very big height. I'm going to give 4000 pixels as a height and let's see what it gives. So you can see that now I can scroll, okay, but I'm scrolling too much because in reality, the height of my content is smaller than 4000. But it's even worse than that because if I resize my window this way, you can see that now the height of my content is more than 4000. So I can still not see all the content. What we are missing is to get the height of the content of the stack layout. And this height changes when we change the size of the window. In Kivy, this height is computed in the stack layout as the minimum height. We can use it by doing self.minimum height. This value is computed in the stack layout and it corresponds to the actual height of the content in the stack layout. Let's try it again. And you can see that this time my scroll is correct and it's just stopping at the end. And if I resize my window, I can still scroll to the end of the content. Also, the scroll view can work with any kind of layouts, but you have to make sure that you specify the size so it can scroll properly. And you can choose to scroll vertically like we did, or also to scroll horizontally. That's all that I wanted to show you with the scroll view. Let's continue on the project. We have finished on the scroll view and we move to the page layout. The page layout makes it possible to go from a layout to another one, just like a book. So we can go from the right to left to go to the next one or to go back by sliding on the other side. I'm going to show you that. So we are going to create a page layout example, which is a page layout. And it's going to be our main interface. Inside, we just put the different layouts that are going to be displayed as a page. So, for example, we first display the main widget. It's not a layout, it's a widget, but it's going to work also. Main widget, then we can go with our box layout example. And then, for example, we can go with the anchor layout example. And then we will put a last one, maybe the grid layout example. Okay, so let's try this. You can see that we get some kind of weird animation at the start. And I will explain you why we have some strange display with this page layout. So first we have our main widget with the hello button and the hello to label. Okay. And you can see that we have something on this side that we can just slide and then we move to the next one, which is the box layout example. But we can still see that something is displayed on the background, especially if I move it here. That's because the black parts that you see here, it's not black color. In fact, it's transparent. And because we don't have any color in the background of our layouts, then it makes some strange display. It's something we are going to solve when we will see the canvas section of this project. Then you can see I can go back by sliding from this side, or I can move to the next one. And the next one is the anchor layout. So once again, all of this part is transparent, so we can still see the previous layout, which is the box layout example, but I cannot click on them anymore. And then we can move to the next one. So I will show you in this course how to improve the display of this page layout by adding some background colors. And also in this course, we will see how to create different screens in our applications. That's not really the case here. Here is just a special layout that takes other layouts inside. But I will show you how to really make different screens and how to navigate between these different screens. That's all for the page layout. Let's conclude on the first part of this project. So we saw many examples about the layouts. It may be a lot of information that we saw here, but you don't need to remember everything. What is the most important is to understand how works a box layout, for example. And then I advise you to practice on your side, to recreate a new project and to use a box layout, to put some elements, to change the size, to experiment on your side. It's very important. The syntax of the KV file is the most important. Also, we learn about the syntax in the Python code. It's something that we will use in some other project, but it's something that is less common than using directly the KV file. And you can see that the syntax is very efficient and that in a few lines we can display some content. Of course, here the content that we'll display is not very graphical, not very beautiful, but that was not the objective. The objective was to learn how to place the different content. And with all that layout strategies, we will know later how to create a screen from a graphical design. And that's what we will do inside this project later when we will create the menu, for example. So practice on your side, and also if you want to have more informations, you can type on Google Kivy layout and you will find this first link. And then you can search in the official documentation if you want to get more details or to see more properties. Like for example, if I go to the box layout, they have some examples in Python code or they have some examples in the KV file. So you may find some extra information, but all the most important information is what I already show you in this section. We will continue to practice with the layouts inside this project and also in other projects. But next we are going to focus on the widgets, because now we only use the button and the label widget, but many other widgets are available, like the image, the slider, and so on. And that's what we are going to see in the next section.
Everything is complete for the layouts, but just before jumping to the widgets, let me show you a practical example. If we look at the MrBeat screen, how do you think I have created this layout? In fact, this screen is mostly a combination of box layouts and relative layouts. First, we have a vertical box layout that allows us to stack what I call the top layout and the bottom layout. The top layout is a relative layout, so we can use the pose hint property to center or to align on a side. On the left, we have the logo image. Then for the play and stop buttons, we have a box layout centered horizontally. And for the BPM, it's a box layout aligned to the right. For the bottom layout, we stack vertically a play indicator widget. It's a widget that we create in this project and that uses a horizontal box layout. The play indicator shows where you are currently playing. And then we have a scroll view. It only scrolls vertically and it includes a vertical box layout so that we can insert all the different tracks. Each track widget is dynamically built from the code so that we can easily change the number of steps. That's the buttons you see here, and it will stack them horizontally. With the MrBeat project, you will practice your skills both on the Kivy library and on the Python language. We will develop some algorithms to manage the audio part. We will create a real-time audio engine. We will mix all the sounds and all will be perfectly synchronized at the sample precision. We will also analyze our code and rework it to optimize the performances of our program. And you will see that it will make a huge difference. I already told you this project is only available on my Python full course. Okay, let's continue on our project with the widgets section. Let's do it.
The lab project widgets version. Let me show you a demo of that project. You will learn how to use toggle buttons to enable or disable other controls. Then you will learn how to manage the click of a button and interact with other controls. Here in this label, we use a custom font, and then you will learn about the switch, the slider, the progress bar, and also text input. After that, I will show you how to add some image and how to control the display. The objective is to continue learning about Kivy, and we are going to practice around the widgets, how to manage the click of a button. We are going to learn how to use new widgets like the toggle button, the switch, the slider, and how to display images. I will show you new things about the KV file syntax, like using the properties and the use of the ID property to connect different controls. We are going to progress with 4 steps. First step is to implement a counter. You will see how to manage the click of a button, how to use a custom font. I will also show you the toggle button and the disabled state. Step number 2, I will show you the ID syntax in the KV file. And you will also learn about the switch, the slider, and the progress bar. Step number 3, we will see how to input some text. And step number 4, we will display some images. Let's start with the step number 1. Let's start to practice with the widgets, and the first thing you are going to learn is how to manage the click of a button. So we are going to create a layout to put our different widgets. For now, we are just going to use a button and a label, but when we will click on the button, we will be able to change the text of the label. So let's start, and we are going to call this widgets example. And we are going to use a grid layout, so it's going to be easy to put many widgets inside the grid. Okay, let's say that we have 3 columns, and I will add a button with a text. So I need to put the semicolon here with the text click here, and we are going to put a label with the text hello, and I will change the main interface with my widgets example. Let's try it. You see, I have my button, click here, and I have my text hello. Now we are going to see how to manage the click of the button. And at first we are just going to print a trace here, and after I will show you how to change the text of the label when we click on the button. On the button you have a property called onPress, so we are going to add that, onPress. And here we can give some Python code, so we will call a function here. But first we are going to create that function. For that I will need to define the class of widgets example. So I go back to my main py and I will create that class widget example. It's a grid layout. Okay, so I can remove this from the KV file because the class is defined. So shall I define the init function? I don't really need the init function because we don't want to create some graphics inside that class. We are just using the KV file for the graphic, but we want to create a function to manage the click of the button. So let's create this function, def, and we can use the name that we want, for example, on button click. Okay, inside this function, I will just print button clicked, and I will use this function name in my KV file on the onPress. On the onPress, I want to say that I want to call this onButtonClick function, and I need to use a parenthesis here because it's like Python code. We don't give the name of the function, we give the Python code that we want to execute when we click on the button. The onButtonClick function is defined inside the widgets example, inside this one. So should I use self? No, not really, because self concerns the button. If I want to speak about widgets example, I need to use root. Okay, let's try it. And you can see that if I click on the button, I have my button click trace that is displayed here. Okay, we can try multiple times. Perfect. So now let's change the text of the label when we click on the button. And for this, you are going to use a custom property. So let's say that in the widgets example, we have a property called myText, and that is equal to a string property. You need to import that. Import Kivy properties. From Kivy properties, import string property. A string property is working like a string, so we can give a default value, for example, hello, and I will add an exclamation sign. Okay, so now let's say that my text is used by the label. So the label text is going to be my text, and again we need to put root.mytext. We say that we have a binding. That means that the text of the label will always be the content of myText property, even if myText property is changed, even if we change the content of my text property, it's going to be automatically linked here. And that's why this KV syntax is very easy and very powerful. If I restart, you can see that now I have hello with an exclamation sign. But when I click on my button, I will change my text. So take care, because you need to use self.myText. If you forget to use self, it's going to be a local variable and it's not going to work. Save my text, we can use it like a standard string. I can do equal to something. And I will say you clicked. Okay, let's try it. And you can see that if I click on my button, I can see you clicked. It's as simple as this. So remember that this is a binding. When I update the content, it's going to be automatically updated on the property of my control. And also remember the onPress property on the button, and that you have to give some Python code here. So don't forget to put the parentheses. That's all for the click of the button. Let's continue on the project. For this exercise, you are going to change the code that we have developed here so that we can count when we click on the button. So at first, it will be displayed 1, and when you click, then it will be 2, and then 3, 4, 5, okay? What you need to do is only to change the code here in the Python file. You will not change anything in the KV file. We don't change the graphics here. In your Python code, you will need to add a new variable, count, that you will initialize to the value 1. When you click on the button, you will increment this variable, and you have to make sure that you display the content of your int variable in myText property. It's your time to practice, and after I will show you the solution. First thing to do is to create our variable. So I'm going to create the count variable that I will initialize to 1. Then for the text, we are also going to display 1 at first. When we click on the button, we are going to increment this variable. So for example, I can use count plus equal 1, and take care, you need to put self to use this variable. Okay, how can I display the content of this variable? In self myText, I can say it's equal to self.count. How can I convert an int to a string? I can use the str function. Okay, so let's try it. You can see I have 1. When I click on the button, I still have 1. So we have a little bug here. But when I click again, it begins to count 2, 3, 4, 5. Can you see where is the bug? In reality, count is equal to 1. So when I click for the first time, I will still display 1, and I will increment the variable after. So I need to increment it before. So it's going to be 2, and then I will display 2 at the first click. Let's try it one more time. You can see I have 1, 2, 3. So my counter is working great. I'm just going to change a little bit the text here, and I will say count. Okay, so everything is complete for this exercise. Let's move on to the next lecture. I am going to show you a few things about the label, and we are going to use a custom font. You have access to the download link of this resource folder where you have the fonts directory and this file lcd.ttf. You will need to copy that inside your project. Here in PyCharm, you can use the main file and do a right click, and you will see that option Reveal in Finder. On PC Windows, it's Show in Explorer. Okay, so I will open my folder Reveal in Finder. And here I will copy this fonts directory inside my project. Okay, when it's done, you will see this fonts directory appearing here inside your project. If you are on Visual Studio Code, you just go to the folder of your project and you copy paste this folder inside your project folder. You will not see this folder appearing in your project, but if you have copied the files correctly, it's going to work anyway. So now let's use a property on the label to use this custom font. I'm going to use font name, and the name of the file is lcd.ttf with an uppercase here, but we also need to give the name of the directory fonts. So I'm going to write fonts/lcd.ttf. Okay, let's try it. you can see that now my label is displayed a bit differently, but it's very small. So let's increase the size of the text. Font size, and let's say we want something quite big. So 80 dp, for example. Let's try it. So now we have our LCD font displayed on the label, okay? And I can still continue to change the color, for example. If I want to use a different color, I can say 100% red, half green, and 100% blue, and totally visible, okay? And it's still working well. That's all that I wanted to show you about the label and the font. Let's continue on the project. I am going to show you how to use a new widget, which is the toggle button. The toggle button is like a button, but it has a state like a switch on and off. Let's add this toggle button as the first element. Toggle button. And we are just going to put a text that is going to be toggle. So let's see how this button behaves. You can see that from the display perspective, it's exactly like a button. But if I click on it, you can see it has a state. It's activated and deactivated, okay? And the standard button is just a click button, but it has no state. So how can we manage the state of the button? To manage the state of the button, we are not going to use onPress, but we are going to use onState. When the state of the button changes, we are going to call a function. For example, root.onToggleButtonState, okay? And I will need to create this new function inside my widget example. Def onToggleButtonState, and I will print toggle state. Let's try it. You can see that now when I click on my toggle button, I have this toggle state print that is displayed. Okay, but how can I get the state of the button? How can I know that it is activated or deactivated? Inside the toggle button, there is a property called state, and we want to get that value inside our function. So how can I get that? I'm going to do something that we are going to use again and again. It's to pass the self argument here. I'm going to pass the toggle button itself in my function. If you go to my function, we have self here, but self here is for the object-oriented programming. It's concerning the widget example, but the argument itself is going to be the toggle button. So I can write toggle button, for example, or I can rename it to widget. And you will see that we will often do that, passing the self and getting the widget here. So now I can use my widget.state. The state is a string of characters, so I can just display it. And let's see what we have. So you can see that when I click on it, when it's activated, we have the state down. And when it's deactivated, we have the state normal. So it's not activated, deactivated, it's normal and down, okay? So for example, let's change the text of the button to on and off. How can I do that? I can test if widget.state is equal to normal, then it's going to be the off case. Else, it's going to be the on case. How can I change the text of my button? Previously, we saw how to do that with a custom property. But look, here we already have the widget. So we can use widget.text and change the text property to off directly. And I will do the same for on here. If I retry, you can see that when I click on it, I have on, then off, on and off. Okay. So now I'm going to improve a little bit my display. I want to initialize directly the text to off and also to change the size to be 100 dp width. So let's do that. At first, I will display off and I'm going to have a fixed width of 100 dp. So I can use size hint and use none for the width and 1 for the height, 100%. And for the width, I will give 100 dp. Okay. Let's try that. It's initialized to off, then on, then off. Okay, perfect. In the next video, we are going to continue to practice on the toggle button with an exercise. For this exercise, you will use the toggle button on or off to activate or deactivate the counter. In every case, it will be possible to click on the count button even if it is off, but in the case it's off, when you will click on it, it will not increment the counter. It should only be possible to increment it when the toggle button is on. I let you practice on this exercise. It's time to practice on your side. When we click on the button, we need to know the state of the toggle button. Because if the toggle button is in normal mode, displaying off, we should not increment the count and not update the text of the label. So we can use a new variable, for example, count enabled, that is going to be false as a default. And when we click on the toggle button, self.countEnabled is going to be true, and it's going to be false again if we switch to off, false. And then only if count is enabled, I will do these lines. So I add a condition if self.countEnabled, then I will increment and I will update the text. Let's try it. You can see that as a default it's off. I can click on the button, but it's not incrementing. Now I activate the counter and now it's working. I can switch it back to off at any time and on again. Everything is okay for this exercise. Let's go a little bit further on what we did previously. You can see that when the toggle is off, we can still click on the button. I am going to show you how to disable this button, so it's not going to be possible anymore to click on it when we are in the off state. If I go back to the KV file and if I go to my button, I can use the disabled property. As a default, disabled is false. That means the button is enabled. But if I put disabled to true, then in this case, it's no more possible to click on the button. So we are going to change that disabled state depending on the state of the toggle button. How can we do that? We already have a variable that says if the count is enabled or not. So we want to use this inside the KV file for this disabled property. To do that, I need to have a property, so we can use a Boolean property. And we need to import that, so it's KV properties Boolean property. Now that we have a property, we can use it in the KV file. I will take count enabled and I will use it in the disable here, root.countEnabled. When the count is enabled, it's going to be true. It means the button is going to be disabled, so that's not what we want to do. We will need to do the opposite. When the count is enabled, we want to put false in disable to enable the button. But let's just try it like this. You can see that in the off state, my button is enabled, and in the on state, my button is disabled. How can I do the opposite as this? I can use the not in front of the property to invert the Boolean. If it's true, it's going to be false, and if it's false, it's going to be true. Okay? If I retry, you can see that in the off state, I cannot click on the button, and in the on state, I can click on it and I can count. And also you can use this disabled property on other widgets that has user interaction. That's all for the disabled property. Let's move on to the next lecture. We have completed the step number 1 and we move to the step number 2. Let's continue, and I'm going to show you how to use a new widget, the switch. The switch is working a bit like the toggle button. It's going to switch between on and off. It will have a different display and also it will use different properties. Let's add the switch in our layout. I will write switch and then we start to see what we have. We have our switch displayed here and we can see we can change it from on to off. Okay, perfect. Now we have a small display problem here. You remember that we gave 100 dp for this button, so I will need to give 100 dp for this switch so that the colon can have a width of 100 dp. So let's do that. I will copy this size hint and the width and paste it inside the switch. Let's try it. Okay, so this time my colon is 100 dp, and now we want to get the state of that switch. It's not going to be an on state, it's going to be an on active. So I will use on active and I will call a function on the widget example that we will call on switch active. And I will create that function inside the code here at the bottom, def on switch active. And because we pass the self, which is the switch itself, we will get this widget parameter. And then I will print the active property. Print switch plus widget.active. The active property is a boolean, so I will convert it to a string with str. Okay, let's try that. You can see that if I click on my switch, it's going to be true and then false, so I can get the state of my switch. Perfect. In the next lecture, we are going to use this switch to enable or disable some other controls, the same way that we did for the count button. That's all for the switch. Let's continue. I am going to show you how to use the slider widget. Slider widget can be a horizontal bar to select a value between a minimum, generally 0, and a maximum 100. Or it can be also a vertical bar. So let's use the slider. I will put it just after the switch, slider, and we are going to give minimum 0. Also, I need to put semicolon here. Okay, maximum 100. These are the default values. Okay, and let's try it like this. So if I restart, we can see that the slider is here. I will show you how to get the value, but before you can see that at first the position was totally on the left. So totally on the left means 0 and totally on the right means 100. What happens if I put a default value to 50, for example? Then you can see that the position of the slider is on 50. And also I can change the orientation to vertical. Okay, so now let's get the value of the slider. We can use the on value and we are going to call a new function in our class. So I will call it on slider value and I will pass the slider here. Again, inside the widgets example class, we are going to go totally at the bottom and to use def on slider value self widget. And I will print slider and we are going to print the value widget.value. The value, of course, is not a string, it's a number, so I need to convert it with str. Let's try this. If I change the value, you can see I get the value displayed here, so it's 0 at the bottom and it's 100 at the top. And we can also see that it's a float value. How can I convert it to an int? I can use int here just before the conversion to the string. And then if I restart again, this time I get an int value. Okay, that's all for now. Let's continue. For this exercise, you are going to add a label here and to display the value of the slider. So when we will change the slider, you will display the int value of the slider that we currently print, and you will display it here. You will need to add a label in the KV file, and you will need to use a new property, string property, that you will call slider value txt. It's your time to practice. First thing I will do is to create the new label, and I will put text slider value. Okay, if I restart, we can see that we have our label here and we need to display the value. To do that, we are going to create a new property, slider value text, which is going to be equal to a default value of value, for example. And we are going to use that in the label text root.slider value text. Of course, I need to update my slider value text when we change the value. It's on the slider value. I will do self.slider value text equal to str int of the widget value. Okay, let's try it. We can see that if I change the slider, I can see the value of my slider. That was the objective of the exercise, but now I'm going to go further and I'm going to show you a new syntax that is more efficient and that will avoid using this new property. So I will just go backward and comment this, also comment this slide, and I will use a fixed value in my label, for example, value. Okay, I start again and you can see that value is displayed and it's no more working. Okay. I am going to use something new. It's called ID. ID makes it possible to use a kind of variable inside the KV file. And I will say that slider is my slider. Then I can directly use my slider inside the text property of the label. And I can say that I want to bind my slider dot value. And of course, I need to convert it to a string. As simple as this. Let's try it. And you can see that I can change the value of my slider and I can see the value here. Of course, I can convert it to an int if I want. It's going to work. Okay, let's try again. Okay, it's working fine. And also you can see that we don't need anymore the on value here. I will just comment it. We were just using it for the print, but I'm going to comment it and you can see that it is still working. Perfect. So what we did is to use ID and to put a name. You can put the name that you want here like a variable. And inside my label, when I do this, we do a binding. So automatically, when the value of my slider is changing, the text of the label will be updated. That's a very simple and very efficient syntax. That's all for this exercise. You are now going to use the switch to enable or disable the slider. And you are going to do this only in the KV file. For this exercise, I don't want any modifications in the Python file. You will need to use the ID syntax like we did previously. You will need to use the disabled property and also to use the active property of the switch. Also, I want the switch to be activated as a default when we start the program. It's your time to practice. I want to enable or disable the slider. So I will use the disabled property. We need to put something here. What do we need to put? We need to put something depending on the active property of the switch. You remember that we used previously this active property, which is a Boolean. And so I will need to use an ID on the switch. My switch, for example. Okay, so here in the slider disabled, I will use my switch dot active. If the switch is active, it will be true. So it means disabled is true. That means the slider will be disabled. That's not what we want. So we will do not before to have the opposite. Let's try that. Okay, you can see that the switch is off. I cannot use the slider. It's disabled. When the switch is on, I can use it. Perfect. So now I want the switch to be on the on position as a default. So we are going to use active and put it to true. And because it's a binding, when I will start the program, the slider is going to be also activated. That's all for this exercise. I will show you how to display and use a progress bar. And this progress bar, we are going to link it to the value of the slider. So I want to display it just under the label. How we can do that? We can stack the label and the progress bar inside a box layout. And this box layout is going to be vertical. So I will use orientation vertical. Okay. Below the label, I'm going to add a progress bar. For now, I don't use any properties. Let's have a look. Okay, you can see my progress bar is displayed here. For now, it's just a line. But if I use some properties, like for example, the maximum value to 100, the minimal value in a progress bar is always 0. You cannot customize it, okay? But for the max, I give 100. And for example, I can use value and give 25. So if I start, you can see that the progress bar is at 25%. Now I want to use the value of the slider to be displayed in the progress bar. How can I do that? I can just copy my slider.value and paste that in the value of the progress bar. Let's try it. Now you can see that we start at 50% and that the value is changing with the slider. That's all for the progress bar. We have completed step number 2. We go to step number 3, text input. we are going to use the text input so that the user can input some text in the interface. And we are going to use that just below the box layout. I will write text input, okay? And we are going to start it just like this. So we can see this box here where I can enter some text. And because we want to keep this colon of 100 dp, I'm going to resize my text input. I will copy size hint and the width just here. Okay, so I have my text input here, and you can see I can type some text. I will show you how to put a default text and also how to get the text and display it on a label. So let's do that. For example, the default text is going to be foo. So if I restart, you can see that the default text is displayed here, and I can also change it, okay? And when I press enter, I can change the lines. So it's a multiple line as a default. I will show you later how to change that. But first, let's use a label. So here I will add a label. How can I display the text of my text input inside my label? I will use text, and here I will use an ID, my text input. And I will use this ID, my text input dot text. And if I do that, you see that I have a binding. That means I display foo. And when I change the text input, it's automatically updated, even if I use multiple lines. Perfect. Now let's say that we want to change the behavior and that we want to use only one line in the text input. But I will update, and I will also update the label only when I will press enter here to confirm the line. So let's do that. I can use the property multi-line and set it to false. As a default, the text input is multi-line. If I do this, you can see that now, if I change the content here and if I press enter, the color is changing a little bit. I don't go to a next line, but the text has been validated. But I want to change a bit this behavior, because you can see that when I update the text, the label is automatically updated. I want to update the label only when I will press enter. For this, we are going to use onTextValidate. This onTextValidate, and we are going to define a new function that is going to be called only when we validate the text. That means when we press enter on the line. Root.onTextValidate, and I will give the text input with the self. And I will create this new function at the end of the widget example class. Def onTextValidate with widget. Okay. I am going to change this binding, so I'm going to remove that, and we are going to create a new string property in the code. So I will copy paste that, and I will call it text input str. As a default, we are going to put foo. Okay. Text input str is what I'm going to display in my label. So I'm going to write root.textInputStr. Okay. So now text input str, I'm going to update it only when I validate my text, when I press enter. So here I will have self text input str is going to take the new text of the widget equal widget.text. Okay, let's try it. So now you can see I have foo. If I update some content here, it's not updating the label, but if I press enter, it's updated. And also what we can do is, for example, in the text, I can add another string here. I can concatenate with a string, and I can say your name is, okay. So if I do that, your name is foo. If I write Brian, enter, your name is Brian. That's all for the text input. We have completed the step number 3, and we move to the images. First thing, you will copy the image folder to your project like we did previously. You will find that folder inside the resource folder that you have downloaded. When it's complete, you will see image folder appearing inside your project. We are going to start with a new example because previously we have added many things inside the screen, so I want to go back from an empty screen. We are going to create a new example, image example, and it's going to be a grid layout. I'm going to reuse the same thing with 3 columns. and it's going to be my main interface. So if I restart, we have an empty screen. Okay, inside I will add an image, and to select the image file, you will use the source property. We are going to display the cake. You will first need to put the folder name images/cake.jpg. Okay, let's start this. You can see that the cake is displayed. If I resize the window, the image is resized, and you can also see that the ratio aspect of the image is preserved. So if I reduce the width, it's reduced, and also if I reduce the height, it's also resized. But you can see that when I expand the window, it's going to be resized of its original size in the file. It's not going to expand. I am going to show you how to do that by using some new properties. So first, let's copy this image 3 times. Okay, so we have something like this, and I'm going to use a new property that is allow stretch, and I'm going to give true. Okay, let's see what happens. You can see that the second image is now able to stretch. That means to expand to a bigger size than the original size. And why it's not stretching to the first image? It's because the 3 elements have the same size here. So it's actually expanding to the size that the layout gives to the image. Okay, let's continue with some other properties, and I'm going to show you how to use keep ratio. As a default, keep ratio is true. Now we are going to give false to say that we don't need to keep the aspect ratio of that image. And we apply this to the third image. If I restart, you can see that strangely it's no effect on that image. And that's because this property can only be used with the allow stretch. So you need to specify allow stretch to true and also combine it with the keep ratio to false. Let's retry, and this time you can see that the ratio is not preserved, but the image will take all the allocated space. So it's not really rendering well for that kind of image, but it's going to be useful for background image like gradients. If you look at the files here, you see we have this JPEG file, and we have also PNG files that we will use later in this project. The difference between PNG and JPEG is that PNG can have transparency. JPEG cannot have transparency, but it can compress better than the PNG. That's all concerning the images.
That's all for the widgets. You might ask me, is it possible to create an application with multiple screens? And how can we go from one screen to another? Yes, it's possible. And that's what we call the navigation. In Kivy, there is a class named the Screen Manager. You can search on Google for Screen Manager Kivy, and you will find some examples. In my Python full course, I will cover the navigation. You will learn how to create multiple screens, how to manage a navigation stack, so you can push new screens and also pop to go back to the previous screen. We will also use the action bar. And all of this works for every platform, including iOS and Android. Okay, let's go back to our project and we move to the canvas section. You will learn how to draw lines and shapes on the screen. Let's do it.
The lab project canvas version, let me show you a demonstration of that project. You can see a new button here, canvas, and we can access to all the canvas examples that we are going to create together. Canvas makes it possible to draw some shapes on the screen. For example here, an ellipse, a rectangle, and also a spring that can adapt to the window width. You will see how to center items, how to change the colors, and also how to move some shapes on the screen. The objective is to learn how to display graphical instructions on the screen, like line, rectangles, circles, and so on. You will understand the interaction of the canvas with the widgets. You will see how to move instructions on the screen, like we will do for the ball. And also you will see how to call a function at a regular interval of time. We will create an update function that we will call 60 times per second. Concerning the instructions, you will learn how to draw a rectangle by giving a position and a size. Same for the ellipse, position and size. And also you will learn how to use the line instructions to draw lines from multiple points and also to draw rectangle and to draw ellipse. Then you will see the color instruction and give the three components red, green, blue. We are going to add instructions in the KV file, but also in the code. Concerning the KV file, you have a sample here. You can see that we add the graphical instructions inside a canvas. And the canvas is inside a widget. It can be any widget like a layout, or it can be a button. What is important is to remember that the instructions is like a list. The order of the instructions are important. For example, here we have a red color and here we have a blue color. On the screen, you can see that the circle and the ellipse are red, but the rectangle is blue. Here I have the width, which is here the circle is drawn at 200x and 200y and 100 radius. The width is the thickness of the line. In the code, it's going to be the same principle, but the syntax is different. For example, here we are going to draw an ellipse at a position and a size. And what is important is that we can remember the instruction inside a variable. Here, the ball variable. And it's possible to update the instruction. For example, here we can update the position of the instruction. So at the start, the ball is drawn at 100, 100. But then by just changing the position property on the ball is going to move at 200, 100. We don't need to call again ellipse. Ellipse is already in the screen, but the instruction automatically knows that it needs to be redrawn when we change the properties. We are going to go forward in multiple steps. First step, I'm going to show you how to use the instructions in the KV file, like the rectangle, the ellipse, the line, and the color. Then we are going to do that inside the code. Then I will show you how to do movements like the ball, and I will explain you the coordinates system. We will see the exception with the relative layout. And finally, we will improve the page layout by adding backgrounds to the different pages. And also we will create the menu for the different canvas examples. Are you ready to start? Let's do it. Okay, let's start with the canvas section. First thing we will do is to define a canvas example number 1. So in your main.py, you will add a new class canvas example 1, and it's going to be a widget. Okay, and I will add pass inside this class. In the KV file, you are going to create this example, canvas example 1. Okay, and inside I will do tab canvas semicolon, and I will define this new canvas example as the main interface. Okay, so take care because this first line here is very important. That is what we call the main interface. So when we will do some other examples like canvas example 2, canvas example 3, you will need to replace it on this first line here to change your main interface. Okay, now have a look, because for the remaining of this tutorial, the list of files is going to be different. It's because the videos are extracted from my full Python course. However, I did not include the navigation part in these tutorials, so the list of files is going to be different. But it will be very simple, because instead of working in canvasexample.kv and canvasexample.py, you will always work in the main.py and the lab.kv. So for example here, in canvasexample.kv, you will not create a new file, you will not create this file, but you will do this in your thelab.kv file, just like we did previously. And for the canvasexample.py, also you will not create this file and you will not use this file, but you will just put your class inside your main.py. Let's continue. And you can see that canvas example 1 is a widget. That means that for every widget or every layout, it's possible to add a canvas section. Even inside a button is a widget, so we can add canvas inside a button if you want. Inside canvas, we are going to write the graphical instructions. For example, rectangle. If we start this, you can see a white rectangle on the lower left of your screen. As a default, the color is white, and also as a default, the size is 100 pixels per 100 pixels. We can change the position and the size by using pos property. And here I will put the position in dp, dp of 100 and dp of 200 for the y. And for the size, I can give dp 150 and also dp 150 to get a square. So let's try it. Okay, we have our rectangle here, 100 dp, 200 dp, and 150 for the size. Of course, we can use pixels directly, and sometimes in the examples, I will use only pixels. But as a good practice, use always dp. dp in your programs. Also, take care because the syntax inside the canvas is different than the syntax directly inside the widget. Let's continue. How can I display my rectangle at the center of the screen? I can change the position and use self.center. But you can see that if I do that, in fact, my rectangle is not centered because the position corresponds to the lower left point. So I will need to subtract the half of the width and the half of the height. So let's do that, but before I want to show you something new. It's possible in the KV file to define some variables. And the syntax is hash semicolon set and then the name of the variable. For us, it's going to be the size. So we can say s and we give the value dp of 150. So here I can replace by s and s. So if I restart, you can see we still have the same thing. Concerning the center, I can use center x and self.center y. Still, I will have the same thing here, but now it's going to be easy to subtract the values. X, I'm going to subtract the half, s divided by 2, and the same for the y. Let's try it. You can see that this time my square is centered in the window. And because we are in the KV file, it's bindings. So when I resize the window, my position is automatically updated. I show you another instruction, which is the ellipse. With the ellipse, you can draw circle or ellipse. And it's working the same way. You give the position and also the size. For the position, for example, I will give 200 pixels and 500 for the Y. And for the size, I can give for the width S and for the height S divided by 2. Let's try it. You can see the ellipse is displayed here. That's all for this first part. Let's continue. I am going to show you how to draw lines with the line instruction. The line instruction uses different properties. We are going to define some points with points, and it's going to be a tuple of x and y and x2, y2 to define the different points. So let's start from 0 to 0 and go to a second point, which is located to x equal 100 and y equal 100. Let's try this. You see that we have a line here starting from 0, 0, lower left, and going to 100, 100. But then we can add some other points. For example, I can write 200, 0. So we have here another segment located at 200, 0. Okay. And we can also say we want to go to the width of the window, self.width to be totally on the right and go at 100. Okay. Let's try that. You can see that we have a last segment that will depend on the window width. We can go further in this example and draw a spring that will adapt on the window width. Let's do that. For example, I'm going to create points at every quarter of the window. So I will use self-width divided by 4 and go to 100. Then I will have self-width divided by 2 going to 0. Then self-width multiplied by 3 divided by 4 and go to 100, and finally width going to 0. Let's try it, and you can see we have the spring that adapts to the window width. Perfect. We can also use another property to change the width of the line, and I can use here width and I can say 2, and you can see that the line is thicker. That's all for this example concerning the line. Let's do an exercise. First, we are going to create the canvas example 2. So we are going to define this in the KV file with canvas inside. Okay. In the Python file, we are going to create canvas example 2. Okay, let's start the program. You can see that we have an empty screen. For this exercise, you will need to draw a cross. You will have a vertical line centered in the screen, and you will have a horizontal line centered in the screen. And of course, if you resize the window, it has to adapt always to the center of the screen. it's time to practice on your side. Inside canvas example.kv, I'm going to write the lines instruction. First line, it's going to be, for example, the horizontal line. So I'm going to give the points, and we are going to start on the left of the window. For the X, I'm going to have 0, and for the Y, I'm going to have self.height divided by 2. To get the point on the right, I use self.width and also height divided by 2. Okay, and we can keep the width to 2 so the line is more visible. Let's try that. You can see we have the horizontal line, and when I resize the window, it's always centered vertically. Perfect. Let's add the vertical line. I'm going to copy this instruction. I will delete all the points. For the vertical line, I start in the middle of the screen, so it's going to be self.width divided by 2. If we start from the bottom, y is going to be equal to 0. Then we go to self.width divided by 2, and to the point totally at the top of the screen, self.height. So we have the vertical line and the horizontal line. We have the cross. That's all for the exercise. We continue on the examples. You are going to create canvas example number 3, and I'm going to show you how to draw a rectangle, circle and ellipse by using the line. Previously, we already saw how to draw rectangle and ellipse, but it was filled of colors. Now we are going to draw only the line. So let's create a canvas example 3, and I will go to the Python file to create example number 3. Inside canvas example 3, I will write canvas, and then I will use the line instruction. In the line instruction, we are not going to use the points, but we are going to use new properties like circle. Circle is a tuple, and you will give the center X, center Y, and the radius. For example, I give 200 and 200 for the position and 100 for the radius, and I can use the width property. Let's try that. So you can see I have the circle here, and I can continue with an ellipse. So I will copy that. For the ellipse, it's almost the same, but it's going to be radius X and radius Y. So here, for example, we are going to change the position to 500 and 300. And for the radius, let's say 100 for the X and 200 for the Y. And for example, we can change the width. Let's try that. We can see the ellipse here. Okay, 100 radius for the X and 200 for the Y. And also I can draw a rectangle. For the rectangle, it's going to be the X, Y, width and height. So let's try 800 and 100 for the position, and for the size 300 width and 200 height. Okay, I will keep width 2. Let's try that. And we have a rectangle just here. Perfect. Now I want to show you how to use the colors. Color is an instruction. I can add my color here inside the canvas, color, and I will specify RGB, red, green, blue. If you want a red color, we will give 100 red, 0 and 0 for the blue. Okay, if I start this, you can see that all the shapes are red, and that's because we changed the color here. And all the graphical instructions after the color instructions. That's because the color instructions was before all the other graphical instructions. But if I move this one just after the circle, then you can see that the circle is white default color, and only the ellipse and the rectangle are red. Okay, I will put it back at the beginning, and I will show you something more. I can use also RGBA with the alpha component. As a default, it's 100% visible, but I can use, for example, 30%. And we have something like this. Also, if I want to change only the color of the rectangle, I can use another color instruction. And let's say that we want to display the rectangle in blue. So I will use 0 for red and 100% blue, and also 100% visible. Okay, so this time the rectangle is blue. Previously, we used color as a property on the widget, but inside the Canva, color is an instruction. It's not a property that you will apply to your circle or your ellipse directly. It's a global color property, and all the other graphical instructions after it will take this color. That's all for this example. Let's continue. I'm going to show you how to use the canvas inside the Python code. We are going to create a new example, canvas example 4. Okay, why do we want to use the canvas inside the code? For example, in some case, you will want to use a loop to display many shapes in the canvas. I am going to show you how to use it, and we are going to do similar instructions that we did previously inside the KV file. We are going to create the init function def init, and we are going to call super init with kw args. Okay, if you want to use the canvas, you write with save canvas, and you write the canvas instructions inside this code block. For example, line instruction with points property, and we give the tuple of points 100 for x and y of the first point, and 400, 500 for the second point. Also, you need to import the line instruction, Kivy graphics vertex instruction. Okay, let's try that. You can see we have the line here, and also it's possible to add the other properties like the width equal to. Okay, let's try this. We have width equal to, perfect. I can also continue and use a color instruction, color. Here I will use a green color, 0 red, 100% green, and 0 blue. You need to import color from Kivy graphics, this one. Okay, and I'm going to draw a circle line. You remember that for circle, we need to use the center X, for example, 400, 200, and the radius 80. And I'm going to keep width equal to. Okay, let's try this. Here I have an error because circle is a property. So you need to use circle equal the tuple with the informations. Let's try again. Okay, I have the circle here in green, perfect. And we can continue, we can draw a rectangle the same way that we did previously. Rectangle, it's really the equivalent that we did here. If you look at circle, it's the same name of the property and it's the same logic concerning the different values. For the rectangle, it's going to be the same x, y, width and height. So for example, 700 for the x, 500 for the y, and 150 width and 100 height, and we can change the width, for example, to 5, and I get a rectangle here. Okay, if we want to draw a rectangle filled with some colors, we need to use the rectangle instruction like we did in the KV file at the beginning, and we have to give pos and size properties. So I will give pos equal the position, for example 700 and 200, and size property equal 150, 100, and you need to import rectangle. Okay, let's try that. You can see the filled rectangle displayed here. That's all for this first part concerning the use of the canvas inside the code. We are able to draw some instructions on the screen. Now I will show you how to update the instructions to move them. And for example, we are going to move this rectangle on the right. So let's do that. We will add a button on the interface, and every time we will click on that button, the rectangle will move from 10 dp on the right. First thing we are going to do is to add the button in the interface. I will define the canvas example in the KV file, canvas example 4, and I will add a button. Position, for example, 100 and 400. And for the text, I will say A. Okay, let's try that. So now we have a button on the interface, and we will need to manage the click of the button by using the onPress property. We have to create a new function in canvas example 4. For example, on button A click. Okay, so let's create this function. I go back to the Python file. Inside canvas example 4, I'm going to write def on button A click. Let's just see if it works. So I'm going to add a print foo. Okay, let's try that. And you can see that if I click on the button, we have foo appearing here. So the click of the button is working. Let's continue. Now I want to update the position of this rectangle. To do this, we need to remember the instruction inside a variable, for example, rect variable, and it's going to be an instance variable, so I can use it in another function here. on the button click. To update the instruction, I have to update the properties on it. Here it's the position. So I will write self.rect.pos equal something. It needs to be a tuple with X and Y. And for a first example, I will put 100, 100. Let's try that. You see that if I click on the button, the rectangle moved to the 100 and 100 position. When you update properties on instructions, the Canva detects that he has to redraw the instruction. Let's improve that so we can move the rectangle on the right. With X and Y, I can do this. Get the X and Y from the current position. And I want to update the value of the X. X plus equal, for example, 10 dp. And you need to import dp from the matrix. Okay. And now I will build a new tuple with X and Y. Of course, it's not possible to do something like this, to access to the first item of the tuple and to increment it. Why? Because the tuple is immutable. You cannot change the tuple. So your only way to do this is to assign the property a new tuple. Here I will give the same value of the Y, but I will update the X to be 10 dp more on the right. So let's try this. When I click on the button, you see the rectangle is moving and I can click again and again. That's all for this step. We are able to move the rectangle on the side, but you can see that the rectangle can also go out of the window. And we want to avoid that. We want that at most it's going to be aligned to the right of the screen. And that's what you are going to do as an exercise. I'm going to add some variables here. We are going to add the W for the width and the height of the rectangle, and it's going to be rect.size. Okay. Also, I will add an increment variable that is as a default dp of 10, and that we will use to change the X value. And you will need to add a condition to modify the content of this variable. So sometimes it's only 5 dp if you have only 5 dp remaining on the right, and it will be 0 dp if you are already aligned on the right. For the computation, you will use self.width, which is the width of the window, and you will use also X, which is the left part of the rectangle, and W, which is the width of the rectangle. So for the right border of the rectangle, it's X plus W. It's time for you to practice on this exercise. I will compute the remaining space with a new variable diff. So diff is going to be self.width minus the position of the right border. The position of the right border is X plus W. So let's write this. Diff equal self.width minus X plus W, the right position of the border and the window width. Okay. If diff is less than what we want to increment, so it means we don't have much space left. We are just going to increment by what we have remaining, and maybe it's already 0. So in the case this is 0, we are not going to move our position. It means we are already on the right. But if we have only 5 dp remaining, we are just going to move to 5 more dp to be aligned on the right of the window. And if we have enough space, we will not go inside this condition and we will move off 10 dp. Let's try this. You can see that the rectangle can move, and when it reaches the right of the window, it just stays here. Okay. If I resize the window, it's going to work because self.width is updated. Okay. And if I get a smaller window and if I click on the button, we will compute also the right position. That's all for this exercise. We saw how to move a rectangle by updating the position property, and now I'm going to show you how to move a shape automatically. We are going to call a function with a time interval. In this new example, Canvas example 5, we are going to draw a ball that will move in the screen and that will rebound on the borders. Canvas example 5, I'm going to take the first lines of the Canvas example 4 with the init function and the with canvas. Okay, we are going to draw the ball. To draw the ball, we use ellipse and we use the position, for example, 100, 100, and also the size, for example, 50 dp, and 50 dp. Perfect. You need to import ellipse here. Okay, so if I start this, we can see the ball on the screen. I am going to improve the code. Here I want to define a variable that will be the size of the ball. So I will write self.ball size equal dp50. Perfect. And I will replace this inside my code. Self ball size. Now I want to display my ball in the center of the window. I can use position equal self.center, but you can see that if I use this, it's not going to work. And that's because in the init function, we don't have the size of the window already. It's too early in the initialization of the graphics. So as a default, the window size is only 100 per 100 pixel at that time. So we get only 50 and 50 position here. And if I resize the window, it's not going to change because it's not a binding here. It's not like in the KV file. It's not going to update automatically. It's just a line of code and it has been executed only one time in the init function. So we will need to use another function, and there is a function that is called onSize that it is called when we change the size of the window. So I will write this def onSize and it use arg. Okay, and we are going to add a print to print the size of the window. onSize, and I will add the width str of self.width and the height str self.height. Okay, let's try that. You can see that when we start in the program, we get onSize with the right size of the window because onSize is called later after the init. And when I change the size of the window, we get the print that is called with the new size of the window. So how can I update my code to make the ball displayed at the center of the window? I can use an instance variable self.ball, and I will update the position of the ball when we change the size of the window. Self.ball.position equal self.center. Let's try this. You can see it is working, but that the ball is not totally in the center of the window because the position is the lowest left point. So we will need to subtract the half of the size of the ball. So let's do that. Ball position is the tuple with self-center X and self-center Y, and we are going to subtract self-ball size divided by 2 and do the same for the Y. And if I restart this, you can see that the ball is totally centered. Now, how can I move the ball? We are going to use something new to call a function regularly with an amount of time. At the end of the init function, we are going to add a new line, clock.schedule interval, and we will need to create a new function that we will call the update function, self.update, and we give the time interval. If I put 1, it's going to be called every 1 second. You need to import clock. Take care here, it's not Kivy clock, it's Kivy properties clock. From kivy.properties import clock. Okay, and we need to create the new function def update. You can use the name that you want for this function, but take care because every function called with schedule needs to have a parameter which is dt delta time. I will explain you how to use this parameter in the Galaxy project. Here I will add a print and I will say update. If I start the program, you can see that the print update is called every seconds. How can I speed up this? I can say, for example, 0.5. So it's going to be called every half second or 2 times per second. If I restart, you can see that it is more frequent here. So let's change the position of the ball in this update function. Self ball position equal, so I have X and Y here, and I will say X plus 10 and Y. Okay, if I restart, you can see the ball is changing, but this is quite slow. So how can we update that? That's because we call it only 2 times per second. And you know that for games, we usually refresh 60 times per second, 60 frames per second. So here I will write 1 divided by 60. And I have my ball moving quite quickly. Also, you can change the speed of the ball by changing the amount that you increment every time. For example, 4. And you see the ball is moving in the screen. That's all for this step. The ball can move, but now we want that the ball does not go out of the window, that the ball can rebound. And that's what we are going to do here. The ball is going to move on the X and on the Y and has to rebound on the 4 sides of the screen. But first I'm going to define the speed of the ball. Self.velocity X equal 3dp, and for the Y it's going to be 4dp. And of course, every time we call the update function, here I will remove the +4, the X will be plus equal to self.vx and the Y plus equal to self.vy. And you can see that this time the ball is moving on the X and the Y axis. Perfect. For this exercise, you will need to add some conditions and you will need to test if the ball is going out of the window. Remember that X and Y are the lower left part of the ball. If you want to get the right part and the top part of the ball, you will need to use the self.ball size. And you will need to test with the self width, the width of the window, and the self height, the height of the window. When you want to rebound, we are going to say that the speed is going to be the opposite. Okay? So for example, if your ball goes out of the screen on the right, you are going to invert the speed so that every time you go to the update function, you are going to increment with something negative. So you will go to the left side. And you are going to do the same principle with the VY. It's your time to practice on this exercise. If I start the program, you can see that first the ball goes out of the screen on the top. So we are going to add this first condition. If the Y of the ball, and I want to get the top of the ball. So it's Y plus self ball size. It's greater than the height of the window, self.height. Then we are going to go on the other direction. Self.vy equal minus self.vy. Also, the maximum value of the Y for the ball is going to be self.height minus the ball size. So if you are above this value, I just put the limit on the Y and we go to the other side and we rebound. Let's try this. You can see that the ball rebounds and then goes out of the screen on the right. So I will add this condition. If X plus the right part of the ball, so X plus ball size is greater than self.width, then again the maximum value for the X is self.width minus the ball size. And I'm going to invert the Vx. Okay, let's try this. So now we rebound on the top and we rebound on the right. We need to add the 2 more conditions for the bottom. If Y is less than 0, then Y equal 0. And we rebound on the Y axis. Same thing for the X. If X is less than 0, then X equals 0. And we rebound on the X axis. Let's try that. Okay, we rebound also on the bottom, again on the top and on the left. And if I resize my window, we kept the ball position equal center of the window. But if I release, it's moving again. Everything is complete for this exercise. We are going to create a new example, Canvas example 6. And I'm going to do some experiments with the coordinates of the canvas and also using the canvas with some other widgets that we used previously, like the button. And we are also going to use the relative layout. So let's do that. Canvas example 6, pass. And then I go to the KV file and I create canvas example 6. We are going to start with a button. So I will write button with text A. Okay. I start and I have a button on the lower left of the window. Button is a widget, so I can add a canvas inside my button, canvas, and I will display a rectangle. If we try this, we can see that the rectangle is displayed on top of the button and that the rectangle is displayed at the coordinate 0, 0. This is because the order of the instructions matters. First, the button has been drawn, and after we have added the instruction of the rectangle. We can change the order of the instructions. I can use canvas before to move this instruction before the instructions of the button. In that case, the button is displayed on top of the rectangle. And also you have canvas.after. I will go back with canvas. If I move the button with position, for example, position 100, 100, you can see that only the button moved and not the rectangle. However, the rectangle is inside the canvas of the button, but you need to understand something important here. The canvas is always drawn at position 0, 0, always. It's going to be one exception with a relative layout, and I'm going to show you that. But first, you can see that this is not related to the button. If I use a box layout, for example, I will comment this property. You can see that the canvas of the box layout, even if we change the position to 100, 100, is always at 0, 0. The only difference will be for the relative layout. In that case, you can see that the rectangle moved, and actually it's not exactly what you think. The canvas position is still at 0, 0, but the relative layout moved the canvas space to its position. The relative layout is the only exception that does this. I show you another example. If here I use a box layout and I add two buttons, button with text A and button with text B. If I restart, you can see that strangely the box layout has a small size here of 100 per 100. That's because canvas example is a widget. It's not a layout. A widget does not take care about the position or the size of the children. So he will give a default size for the box layout, which is 100 per 100. If you want to occupy all the window widths, we have to do explicitly size equal to the root.size. In the previous layout examples that we did not have to do that because it was directly a layout and it was not a layout inside a widget. Okay. But here, if I take the size of the widget explicitly, my box layout takes all the size of the window. Perfect. Now I want to draw a rectangle instead of the A button. I can use an empty widget. If I replace button by widget, I have an empty widget here, and I can use a canvas on this widget. Canvas, and I will draw a rectangle. Okay, let's try it. We have the rectangle at 0, 0 in the canvas. And I can use size on the rectangle to get the size of the widget. Self.size. Take care, it's not root.size because root is canvas example 6. Root size will be all the size of the window, but we want to use only self.size because we want to use only the size of this widget. If I restart, you see that we have a white rectangle, and I can change the color by using a color instruction inside the canvas, RGB, for example, green color 010. Okay, I have a green rectangle. How can I do the same for the B button? I want to draw a blue rectangle. I'm going to copy all this section and replace button by a widget with a rectangle that is blue. And you will see that this time the blue rectangle is displayed on the left, because the canvas always starts at 0, 0. So if you want to move the rectangle, we need to give a position to the rectangle, and we are going to give self.position to get the position of the widget. This time it's working. I have the green rectangle on the left and the blue rectangle on the right. Also, we can do the same thing with a relative layout. For example, if I replace widget by relative layout, I can remove the position here because the relative layout will move its canvas to its position. You can see that the blue rectangle is still here. It's drawn at 0, 0, but because of the relative layout, it moved to its position. That's all that I wanted to show you concerning the coordinates and the relative layout. For this exercise, I'm going to ask you to draw 3 rectangles, blue, white, and red, like the French flag. You will create a new example, canvas example 7, but this example is going to be directly a box layout and not a widget. So I will write box layout here. Canvas example 7, take care because you need to import box layout. Okay, so you will do this exercise. Remember that for the white color, you need to use 1, 1, and 1. It's your time to practice. Okay, I will add a first rectangle. I will copy this relative layout that I will put in the box layout, and it's blue. Then I will use a white one with 1 and 1. Also, you can see that if I add only this one, it's going to take all the space of the window automatically because we start with a box layout and not with a widget. Okay, then I add the white one and also the red one. Everything is okay for this exercise.
You have completed the lab project. Congratulations! You are now able to create user interfaces in Python with the Kivy library. But let's go a bit further with Kivy by creating a real-world project. Part number 2, the Galaxy project. Version 1, let's start.
Welcome to the Galaxy project. It is an advanced project. That means you had to follow the previous video of this course and also be able to do all the exercise. If that's not the case, practice a little bit more, and when you are ready, you can start on this project. What is Galaxy? It's a game in 3 dimensions or in perspective mode, and the player has to move the spaceship on the left and on the right to stay on the track. If you go out of the track, you will have a game over. Let me show you a demo of the project.
Galaxy.
So you can see we have a menu, we have also sounds that says Galaxy, and when I press start, the game is starting with some background music. I can go on the left, on the right, and follow the land. I also have the score, which is updated. And if I go out of the track, I go into the game over. And I can also restart the program again and again. The objectives of the project is to create a desktop, Windows, Linux or macOS, or mobile game, iOS and Android, from A to Z. You will practice on apps development with Kivy, especially on the canvas. You will learn how to structure your code and to organize it. You will improve your debugging skills, especially on the errors, but also when we want to improve some behaviors of the game. So you will need to do some investigation. We will need to create some algorithm, so you will practice on the land generation, but also on the perspective display. You will also need to create and implement all the game elements like the land and the ship, and you will code all the game logic. User actions, what we have to do when the user presses left, when the user goes out of the track. You will display the score and trigger the different sounds at the right moment. We will progress on 3 steps. First version, you will display the grid in 2 dimensions, and then you will transform the display to display it in perspective. And finally, we will also add the movement to go forward into the level and also to be able to go on the left and on the right. Step number 2, we will generate the land. I mean the track that we have to follow. We will also display the ship and we will manage the collisions. That means we will observe if the ship is still on the track or if it is out of the track, and in that case we will just print game over. On the V3 we will finalize our project to display the menu, trigger the different sounds, display the background image and manage the score. Why did I choose to create this game? I did not want it to create another Pong or a Flappy Bird or a classic Snake. I wanted to create something new. I started from this concept of a car game in 2 dimensions with a land generation. And I like this idea to practice on a land generation algorithm. So I kept this idea, but I was thinking of something using a grid. So we can have different algorithms concerning the land. But then I also thought about the visual aspect and I was thinking, why not transforming this 2D aspect to a perspective mode? Then I change my concept of the car to a spaceship and have something in the space and have a kind of different levels where you need to reach a planet, something like that. So this choice is to avoid the classics like the Pong, the snakes, to have this land generation algorithm, which is very interesting to learn and to practice on, to have an interesting visual aspect. And also, I don't mean that I created a new game concept. It's other games like this that already exist, but I never saw any existing tutorials about it. So it's something new and exclusive that you will learn into that course. How does it work? In fact, we are going to work in a 2D mode with a grid, and then we are going to transform that into a perspective mode. We will implement this function later, transform perspective. Do you need to be good at math to do this? In fact, not really. I simplified everything, so you just need to understand the compute of proportions. For example, if I tell you that $1 equals 90 cents of euro, how much is €1 in US dollar? In that case is 1 divided by 0.9, 1.111. If you understand this concept, you can follow the mathematics behind the perspective transform. Else, if you really cannot follow mathematical concepts, you will be able to follow these tutorials in 2D mode because all of the logic of the game is done in 2D and the perspective is only to change the coordinates for the display. How does we have this movement of going forward into the game? In reality, we are just going to offset the grid vertically. So for example, if we start with this grid, I put 2 lines in color. We will shift it downstairs. So we have this impression to go forward into the game again and again. And when we will reach this point at the base, we will just loop to go back at the initial position so that we have this illusion that the game is always going forward. I will explain you that in more details later. Concerning the ship movement on the left and on the right, in fact the ship will be always displayed in the center of the screen. And for example, if the user presses the right key, we are going to move the land on the left so that we have this illusion that the ship moves on the right. And this principle is going to work also when we press on the left. Concerning the land generation, I have prepared a simple algorithm. You will be able to go forward, to go on the right, or to go on the left, and it's going to be random. So we will have 3 patterns, just going forward, going on the right, and going on the left, so that we can generate a random and also infinite, because when we go forward into the game, we have some part of the path that will go out of the screen, so we will recycle it to generate new elements at the top. And this is going to be displayed perfectly in perspective so that the player will have to move on the left and on the right to stay on the track. We are going to start right now with the V1. You are going to create the project to define the coordinates of the perspective point, to generate the grid with the vertical and horizontal lines. We will also create the transformation of the coordinates so that we can go from the 2D grid to the perspective mode. Finally, we will also implement the forward movement and also the movement on the left and on the right when the user presses the keyboard keys on computer or press the screen on mobile. Are you ready to start? Let's do it. Let's create our new project. I put the name Galaxy and I will use the same options as usual. I will click on the Create button. When it's ready, we will add the new Python file main and I will begin to write some code. Class Galaxy app coming from the app class, and I will put nothing inside. I need to import the kiwi.app.app. Okay, and I will add my main widget. Class main widget coming from widget, and I will put pass inside and import this. Import Kiwi UIX widget. Okay, and of course I need to instantiate my application, so I need to use parenthesis.run. Okay, and I will also add my KV file, so I need to add not in the VF but put it here, new file galaxy.kv with the same name as the app without app. Okay, galaxy.kv, make sure it is in the same directory as the main.py, and my main interface is going to be my main widget. So I'm going to put main widget semicolon. Okay, I save it and I can start my application by using the right click run, and I have a black screen. Everything is ready for the creation of the project. I want to define the coordinates of our perspective point, and the perspective point will be at the center horizontally and at 75% of the height here. And of course, when we will resize the window, it will automatically update the coordinates of our perspective point. So let's begin by creating some variables. Perspective point X, and let's say it's a numeric property, so we will be able to also modify it from the KV file. Why not? Let's see if we need that. Numeric property 0. And I'm going to copy paste this with Y and import numeric property. Okay, so we need to get the size of the window. Can we get the size of the window from the init? Let's try def init, and I'm going to call super main widget self.init. Okay, and I will add a trace print init. I will put my width. It's going to be str from the self.width. Okay, and the same thing for the height plus str self 8. Okay, let's try it. You see that if I start my program, I have init function that is called, but we have a width and a height of 100 because it is a default size. But of course, it does not match the size of my window. And also if I resize my window, it's not going to work. Is it going to work from the onParent? Let's try widget parent. OnParent is called when we just attach the widget to the app in our case. So I'm going to call the same thing here, the trace, and I'm going to put onParent. Okay, let's try it. You can see that I still don't have the size of my window here. But anyway, let's keep these functions because we will need to use them in the project. I'm just going to comment the print, and because I have no code here, I need to add pass in this function. Okay, it's another function called the onSize with star args. Okay, and let's try it on onSize function, onSize. Here you see that I get a size of 1600 and 1200, which match the size of my window. And if I resize it, I have the new size that is appearing here. Okay, so this is a good candidate to compute our perspective point. I can say that onSize self.perspective point, don't forget to use self here, okay, equal self.width that I'm going to divide by 2. I want to be at the center horizontally, and I'm going to use perspective point Y is going to be self.height at 75%, so I multiply by 0.75. And how can I observe when the property change? I can use a function name that will be automatically called because it's a property, and that is on the name of the property, on perspective point X. When the value of this property change is automatically called, and we need to provide widget and value parameters. So value is going to be the new value. I can add a print, and I will say perspective X, and I will print the value, the new value. Okay, and I will do the same for the Y. Okay, py equal this new value. Let's try it. So you can see 1600, 1200, and I have 800 for X, which is correct, and 900 for the Y, which is also correct. So my point is here, and it's going to automatically adapt when I change the size of the window. Is it possible to do it in a different way? Yes, we can do that from the KV file. So I'm going to comment these 2 lines, and I will do the equivalent on the KV file. Here we have our main interface, which is the main widget, and I'm going also to define my main widget. Inside my main widget, I have these properties, so I can use them. Perspective point X directly in my KV file, and I'm going to give a value, which is self.width divided by 2, and perspective point Y, which is going to be self.height multiplied by 0.75. And if I start again my program, you can see that it's still going to work. you see that the values of my perspective point are automatically updated. How is it possible? Because here we give the value of the width and the height. It's because it's a binding. When you write something like this in the KV file, it will automatically update the value of the property when self.width and self.height will be modified. And of course, these two functions are going to be called whether the value of the property is changed from the Python file or from the KV file. So that's all for the perspective point. I'm going just to comment the print, and we need to put pass because we have no code inside the functions. Okay, and then we can move to the next video. Now we want to display our vertical line. So we are going to display the vertical line in 2 dimensions first, and then we will apply a transform to have the perspective. And we will display a line totally from the bottom, 0, to the height of the window. We will have a line at the center, and we will have other vertical lines spaced by the same amount that we will compute by a percentage on the width of the window. We want our game to adapt to the size of the window. So let's do this, but first we are going to display only one line to make a first test. So I'm going to create a function, init vertical lines, that I'm going to call from the init function, self.init vertical lines. Okay, I'm going to add a line instruction in the canvas with self.canvas, and all the lines will be displayed in white. So I will put a color instruction with 111 for white. I need to import this. KV graphics context instructions. Don't take this one, okay. And I will add a line instruction with points. Take care, it's an S at points equal, and we are going to give a list of points. I need to import this line instruction. KV graphics vertex instructions. First, to make a test, we want to make a vertical line that will be at a X with 100. So we are going to give X1 100, Y1 0, X2 100, Y2 100. Okay, let's save and try this. So you can see we have our vertical line at the good coordinates. Okay, I can resize my window. It's still displayed here. Let's do something more. Let's display this line always at the center of the window. So even when we resize the window, it's going to be updated to the right position depending on the window width. How can I do that? I have to save this line instruction, and I need to create a new variable, line equal none, and I will do self.line equal line. And from that, this line instruction is already in the canvas. I will just update my line. So I'm going to create a function, update vertical lines. And what I want to do is to give my lines new points. Points equal my new points. And I want to display it at the center of the window. So you may say, why I don't put the center here? Like for example, self.width divided by 2. Yeah, why not? So let's try that and see what it gives. And you can see that my line is displayed here and not in the center of the window. Why? Because it took the value 100 divided by 2, 50, that is available at the init here, because we call it from here. Or you may say we need to call this function on the onSize. No, we should not do that, because if we do that, it's going to create over and over new instructions in the canvas, and that's not what we want to do. We want to create only one instruction, so I'm going to remove that from here. We want to call it from the init, that's correct. We create our instruction, and then we will just update the coordinates, but never call that anymore. So I'm just going to update the coordinates in the update vertical lines, and this function, yes, I will call it from the onSize function. Self.update vertical lines. So what I give, X1, I want to give the width. Here I can go back to 100, for example. And here I will compute the center X, which is self.width divided by 2. And you need to give int coordinates. Else, if you have some decimals in the coordinates, the line will be drawn, but not totally well. So you have to take care about that. X1, it's the center X, and 0 for the Y. And then we go to the same X, but 100 in our example. Let's see if it's working well. you see that it's at the center of the window, and if I resize my window, I can see the line is moving and always align to the center of the window. So we can just by assigning new points to this line, you can see that the display is updated. And you may say, okay, but why we did not update it only the Y here and do like points of 0 equals something? Because if you do that, it will not trigger the update of the display. So what you need to do is to give a new value to this points property. Okay, so now that we have one line working and adapting to the size of the window, we want to have our multiple vertical lines. And we are going to start from a center line, but we will have lines on the left and lines on the right. We are going to define the total number of lines, and we are going to define also the spacing between the different lines. And it's going to be, in our case, 10% of the total width of the window. Okay, let's do this. I can delete my line because we will now manage multiple vertical lines. It's going to be a list of lines. And I'm going to create the different numbers that we want. Vertical NB lines, for example, 7 lines. Of course, we will be able to change that numbers later if we want. And vertical lines spacing, that's space between the different lines. And why I don't give a value in dp or in pixels? Because imagine if you're on an iPad or a phone, it's going to be different display size. So we need to adapt the size of our game depending on the size of the window. So I have to give a percentage on the width of the window. I will say that it's going to be 10%, 0.1 percentage in screen width. Okay, perfect. In the init, I will initialize my different lines. So here, I don't want to do that anymore, but I will just add the different instructions in the Canva. I will not give any points. I just want to create my lines, and later in the update, I will reassign the points to each line. So here, I just want to do a new line, and in a loop, of course, for I in range 0 to NB vertical NB lines, I will create a line that I will add in my vertical lines append. I put self. So in my vertical lines, I will have 7 lines in our case. Now, when I go to the update function, I want to reassign my points to each line. So I'm going to comment that. And of course, I will loop, same loop for every lines. I need to assign the points of this vertical line of the index dot points equal something. How can we compute that? What we can compute is the x of the central line. We can rename that to central line x. And what's going to happen, for example, is that we are going to have this central line here, but we need to draw also lines on the left and lines on the right. And we will have 3 lines on the left plus this one, 4, and 3 lines on the right to go to 7. Okay. So what we can do is to have an offset that will be negative at the beginning, and that will be the half of NB lines. So we can do divided by 2. In our case, if I do int of this, it's going to be 3. So I'm going to start on the left, and in my loop, I will increment this offset. So I have a kind of index of the number of the line. It's going to be the -3 line, totally on the left, -2, -1, then 0, 1, 2, 3. And I will then compute the x of the line from the central line and the offset. So I can compute it here. Line x is equal to central line x plus the offset. The offset is negative first, so it's going to be on the left first, multiply by the spacing between the different lines. So it's going to be self.v_lines spacing. But line spacing is a percentage on the window width. So we first need to compute the spacing. I'm going to write it here. Spacing is equal to self.v_lines spacing multiplied by self.width. Okay, and I will multiply my spacing here. Okay, so first, in the first loop, I get my offset -3. I get central line x plus -3 the spacing. So it's going to be the line totally on the left. Then I increment my offset. So from -3, I go to -2. So it's going to be the next vertical line, then -1. Then the center is going to be 0 in the offset. So it's going to be at the central line. And then we have +1 spacing, +2, +3. Of course, now I need to give my points. So x is line x, and I give 0 for the y, then again line x, and I'm going to give the self.height, so we can draw the line totally to the top. Let's try that. Okay, you can see I have my different lines. Something I'm missing, you can see that the drawing of the line is a bit weird, like we have some lines that are more visible than others, is because we need to put the int here in the coordinates. It's important not to have floating numbers. Okay, let's try again. So now you see it's better, and we have our lines that are displayed and that adapts to the width of the window. It's perfect. Of course, we can change these numbers. For example, I can put less here, 0, 4, let's say, and we have more lines. Okay, so why do I put an odd number here? For example, if I put 4 lines and I go back to my 0, 1, what's going to happen? It's because it's not going to be balanced from the center line. We have 2 lines on the left and only 1 here to make 4 lines. So for this to work, we need to have an odd number like 5, 7, 11, for example. So let's keep these values. That's all for the vertical lines, and let's continue on the project. We were able to display our vertical lines in a 2-dimensional space. We use the vertical lines spacing to define the equal space between the different lines, and we also define the vertical number of lines. For example, here 5. Our vertical lines start from a y of 0 to the height of the screen. How can we transform that display to a perspective display? We already have our perspective point, perspective x and perspective y, and we want to display our vertical lines this way. On the axis, when y equals 0, we are going to keep the same value of the v-line spacing. But the more we go closer to the vertical points, the more the horizontal axis is going to be smaller. To do this, we are going to implement a function that we will call transform perspective. It will take the 2D coordinates as an input, and it will return the transform coordinates. For example, if I take this line, which is going to be displayed here in the perspective, I have 2 points. I have this point here, point number 1, and point number 2. You can see that my point number 1 is going to be displayed here at the same position, but the point number 2 will be displayed at the same position as the perspective point. To go from here to here is what I call the version number 1 of our transformation function, because it's going to evolve in the project. We will see that later. So how are we going to go from here to here? It's going to be mathematical computation of linear proportions. If I go back to my perspective representation, I have my x and y axis starting from 0 and going to the maximum y of height and maximum x of width. This is my display. This represents my window. I have my perspective x here for this line and perspective y here. For the example, we are going to take this blue line. It has 2 points. Point number 1 here, x1, y1. This line in the 2-dimensional space is displayed as this red line. So the other point is here, point x2, y2. These 2D coordinates is what I will give to my transformation function as an input. First thing we can compute is about the y transformation. I want that when the y is at the maximum value, which is 8, and which is the case for my point 2, I want it to be at a maximum of perspective y. So I'm going to make a proportion here. If it is 0, we keep 0. If it is 8, we divide by the 8 and we multiply by perspective y to be here. So my transformation y equal point y divided by the maximum 8 and multiply by the perspective y. Also in the code, we will add some condition to avoid going above the perspective y even if you are above the 8. So if I apply this transform y, my point 2 is here. Now we want to compute the x, and you can see that the x is going to be closer and closer to the perspective x. Here I have my diff x, and here I have my diff y. Diff x is the same value for point 1 and point 2. It's going to be the point x minus the perspective x. Concerning diff y, I'm going to use the transform y. So for the point 1, it's going to be perspective y minus 0. So we have the maximum value here, which is perspective y. For the point 2, my point 2 with the transform y is already here. So it's going to be 0, perspective y minus perspective y. Diff y equal perspective y minus the transform y. How can I compute my x? To compute the value of the x, you need to understand that the delta of x depends on the y. The more we go closer to the perspective point vertically, the more my diff x will be smaller. And if I go halfway vertically, my diff x will have a value of 50%. So what we want to have is a proportion variable. That is 1 when diff y is the maximum value, perspective y, and that is 50% when my diff y is at halfway. And we are going to apply this vertical proportion to the difference of x. And we will call that the factor y. Factor y equals the difference y divided by the maximum value, perspective y. Factor y equal 1 in the case of the point number 1, and it equals 0 in the case of point number 2. Because we have 0 in factor y for the point number 2, the transform x will not have any difference with the perspective x. Transform x equal perspective x plus the diff x at the proportion of the factor y. So multiply by factor y. That means that the x for point number 1 will be here, perspective x plus the full difference because we have a full factor y. Then for this point in the middle, we are going to be starting from perspective x plus the half of the diff x. And for the point number 2, we are going to be here plus 0 because of factor y is equal to 0. And of course, for the points on the left, we are going to have a diff x that is negative. So we will add this negative value for the left part. This is correct. And finally, we will return that transform coordinates. Take the time on your side to look about this and maybe watch again this video. And when you are ready, we are going to move to the next video to implement this transformation function. We have our vertical lines and we have our perspective point, and now we want to display the lines in perspective. So how can we do that? You may say we can take this coordinate here and then we take the coordinate of the perspective point and that's it, we trace our lines. Okay, but that's not what I want to do because we will need to trace also the horizontal lines and other elements on the display. So I choose to have another approach, which is to have a transform function. We are going to have a function that will take the input coordinates, x and y. So we will give the two-dimension coordinates in the input, and on the output, we will get the coordinates in perspective. That means if you give this coordinate, for example, you will have the same in the output. But if we give this coordinate here, which correspond to where we trace our 2D line, then you will get this coordinate in the output tracing the line like this. And by using a transform function, we will be able to use multiple transform functions. That will make it possible to have a standard 2D transform that will not transform the coordinates and another function to transform in perspective. So it's going to be easy to change the display from 2D to perspective very easily. I will show you concretely how it works. So first, what we are going to do is to define a new function that is going to be transform. And we will give x and y. And this is going to return something, and this something is the result of a transform function. So we will have transform 2D that will also take x and y, and this one does not change anything, so it just returns x and y. Okay, so our transform function does not do anything for now, but the interest is that we can have another one which is going to be the transform perspective, and this we need to implement it. Okay, that's what we are going to do in this video. And why do I do this? Of course, the transform function, we will need to call it before we display the line. We are going to do that. But why I do this? Because we can use either our 2D transform or transform perspective. So we can go easily from perspective or from 2D, okay? So of course here I return the same coordinate. So if I just use the transform perspective, it's not going to change anything. The interest is what? Is that we will compute all the coordinates in 2D. But just before going to the display, we are going to transform the coordinates. And how can we do that? We are going to compute x1 and y1. That is going to be a self.transform. And it will take the 2D coordinates, line x and 0 in our case, okay? And here we will display x1 and y1. And for x2 and y2, we are going to take the same input, so line x for x and self.height for the y, okay? So I can put x2 and y2. Okay, so if I start my program again, of course, it's going to be the same thing because we don't change the coordinates here. Perfect. So let's begin to write this function. And what we want to do is this. Instead of drawing until the top, we want to draw until the perspective x and y. First, let's compute the y. So for the y, if we give 0, we will still stay here. But if we give the window height, it's going to have a result of the perspective y, okay? So we need to make a proportion to go to this maximum value. That means here I will write transform y that is equal to my value of the y that I'm going to divide by the self.height. Self-height is the height of the window, okay? So when the y equals the maximum value, which is the height of the window, it's going to be a value of 1 here. Self.height divided by self.height equal 1. And this value of 1, I want to multiply it by the self.perspective point y. So when I reach the maximum of the window, in fact, the return coordinate, in fact, the return y of the transform function will be here. And if I go above, then I'm going to be stuck here, okay? So if the transform y is greater than the self-perspective point y, is going to be equal to that. We cannot go after the perspective point. Okay, so I can begin to return this new coordinate here in my transform perspective. Make sure that you use this transform perspective function. And if I try it, you can see that this time I'm stuck here. Okay, it's no more going to the top of the window, but to 75%. Perfect. Also, I'm going always to return int coordinates in the 2D and in the transform perspective, so we are sure we use non-floating coordinates. Okay, it will not change much in my case. Perfect. Now let's compute for the x position. What do we want to do for the x position? For example, if we take this line, you can see that the more we go to the right to reach this x point of the perspective point. And how can we compute that? What we will look is at this x coordinate of the perspective point, and we will compute the difference here. It's what we will call the diff x is going to be 100% when the diff y, because the diff y is going to be perspective y minus the current y coordinate, is going to be equal to the maximum value, which is perspective y. So when we have 100% difference, and the more we decrease the percentage of height proportionally, the more we are going to decrease the difference of the diff x. So let's write the diff x and diff y. Diff x, it's going to be the value of my x, for example, this value here, that is greater than the x of the perspective point. So it's going to be x minus self.perspective point x. But diff y is going to be perspective point y, because this is the greater value here and our y is smaller, minus our try, not the y, because the y can go to the window height, but we want to have the proportion until the perspective point y. So that's why we need to use the try. What is the proportion y? Proportion y will be equal to 1 when we are at the bottom. When diff y equal to perspective point y, okay? And it's going to be equal to 0 when diff y equals 0. So it's a proportion. We want to compute for a y here on this axis, how much proportion we have. Here is going to be 100%, here is going to be 50%, and here it's going to be 75% and 0%. The more we go to the perspective point, we decrease this proportion, because we are going to multiply the different x by this proportion here on the y-axis. So this proportion y is equal to my coordinate, tier y, that I'm going to divide. It's going to be my diff y that I'm going to divide by perspective point y. And you can see that when my diff y is 0, my proportion is 0. But when my diff y is maximum, it's going to have this value, perspective point y. So it's going to have a value of 1. Okay, so my proportion is correct here. How can I compute my transformation x? We are going to start from perspective point x, and we are going to add the difference. But the difference is going to be a factor of this y proportion. Okay, so let's try that. Okay, so we agree that we start from here, perspective point x, and we will add the difference, which is the compute here of the difference, multiply by the factor of the height. That means if I'm at 50%, my difference here is only 50%, which makes a point here. Okay, so let's try that. And you can see that this time it's working well. So I can resize my window in every dimensions. It's working well. I can also change the number of lines and the spacing between the lines. If I put, for example, 25% between the different lines, I have something like this, which is more interesting. And I can also add more lines, for example, 15. Okay, so we have something good. And what is interesting, of course, is that we can change the transformation. Here, I just can uncomment transform 2D and comment the perspective. So I go back to my 2D display, and it's going to be useful when we want to do the development, because all the logic of the program will be in 2D. And at the very last moment, we will transform the coordinates to the perspective. So it's going to be far more easy to work like that. I just go back to perspective and back to the previous numbers here, 7 and 10%. And that's it for the perspective transform. And we move on to the next video. We have our perspective line. Okay, I want to do a slight modification. I don't want to have a line here. I want to have a way here. I want this to be centered, because for our game, we will have our spaceship on a way and not on a line. So what you will do for this exercise is that you will shift the x coordinates so that not a line is centered, but a way. First, I suggest you that you go back to the 2D transform. So you go to transform and you uncomment the 2D and you go back here. And for example, we are going to reduce the number of lines. Of course, it's going to work not with an odd number of lines this time, but with an even number of lines. So I'm going to put 4. You can see that this line is centered, but I want that you shift everything to the right of the half of the spacing. I let you do the exercise and I will show you after the solution. So I want this part, this way, to be centered and not this line. So we need to shift by the half of a line spacing to the right. How can we do that? Of course, it's not going to be in the transform. All the logic of the game is going to be transformed at the end just for the display. But we need to modify the coordinates of the lines that we draw in the update vertical lines. And for example, we can change the central line X coordinate. That's possible to add a half of the spacing here, okay? Or we can just change the offset and to say that the offset is a plus 0.5 plus a half of line, because the offset is going to be multiplied by the spacing. So in case of starting at -2, because in our case we have 4 here, it's going to be -1.5, then -0.5, then +0.5 and +1.5. Okay, So you may say, yes, but I say that we don't use a floating point in the coordinates. Yes, but it's okay here because we are going to multiply by the spacing. And after that, we are going to remove the floating points. So at that stage, it's going to be multiplied first by a spacing that is going to be a quite high number here. Okay, so let's try that. This time we have a way centered in the window. Okay, it's perfect. And we can go back to the perspective mode. And this time you can see that we are centered with a way in the middle. It's perfect. Let's add more lines. For example, 10 lines and a little bit more of spacing. And this time you can understand that it's far better concerning our game. So we will put spaceship here and we will be able to move it horizontally. I will show you that later. That's all for the exercise and we continue on the project. We have our vertical lines, we can display them in perspective, it's nice, and now we want to display also the horizontal lines. I'm going to go back to the 2D display. So I will comment that, okay, and I will reduce the number of lines, just so that it's more clear what we are doing here. I'm going to go back to 4 lines and 10% spacing. So we have this, and what we want to do is to display some horizontal lines. We are going to have the same logic as the vertical lines. We are going to have a number of lines. We will start from y equal 0 from here, and then we will define the spacing for the horizontal lines. We will not start from 0 to the width, but we will need to compute the x min and x max, which will depend on the vertical lines, and we will display our different lines with the same spacing. So let's do that. I'm going to copy paste what we did for the vertical lines, and it's going to be h horizontal number of lines. I'm going to keep this value 4, and horizontal lines spacing, for example, 0.2, 20%, percentage in screen height. And I'm going to call that horizontal lines. Okay, and I will have the same logic, init function and update function. So I'm just going to copy paste that, and it's going to be horizontal, and the same here for the update function, horizontal. Okay, and I will go to take this init and update function, and I just copy paste this code that we will of course change. So first the name of the function, horizontal, okay, and the same for the update function. In the init, it's going to be quite straightforward because it's going to be almost the same thing. We are going to loop on the number of horizontal lines, and we are going to add in our horizontal lines list the different lines. Okay, that's done for the init function. For the update function, it's going to be different. So I'm going just to remove all this code. Update horizontal lines. I want to loop on the number of horizontal line. And what is going to be the line y? And the line y, it's going to start from 0 plus something from the index that we are going to multiply. What do we need to multiply by? The spacing, h line spacing, which is 20% self.h line spacing, 20% of the screen height. Yes, it's called horizontal, but it's for the horizontal line. But this spacing is vertical. So it depends. So it's 20% of the height of the window. It depends on the height. Okay, I don't need to put a 0 plus here. I can just delete it. So we will need to compute the x min and the x max. For now, we just put some values in it. X min 0, x max equal self.width. Okay, we will change that later. So here I can put my coordinates. We start from the point 1 is at x min and the line y for both of them. And the point 2 is at x max. Okay, I don't have any offset in this case, and that's it. So let's try it and see what it gives. I don't have my vertical lines anymore, and this is maybe because I have replaced some code here. Update vertical lines, update horizontal lines. That's correct. It's because I forgot to change here the points of my horizontal lines. Okay, so I was erasing my vertical lines. Make sure you don't have v here and that it's horizontal lines in the horizontal function. Okay, let's try it one more time. and now you can see we have our horizontal lines and it's adapting to the height of the window. That's good. What we need to do now is to compute the x-min and the x-max because I don't want this part here. I want to stop here. And this depends on the vertical lines. If you look at the code for the update vertical lines, you will see that we first compute this offset. So we know the position of the x of the line totally on the left. So we can reuse that. And we are going to keep this computation for the minimum x, the line totally on the left, and we will put a minus for the opposite direction of the offset for the maximum, for the x-max. So I'm going to copy these three lines and to paste them here. Of course, in the same logic here, I can define a spacing y variable. That is going to be my horizontal line spacing multiplied by the height of the window. Okay, I can do that. It's the same thing. But to go back to the computation of x-min and x-max, I'm going to use the central line x plus the offset, which is negative. It's good because we go to the left, it's x-min, multiply by the spacing. And for the max, I'm going to do the same, but I'm going to go to the other direction for the maximum offset. You may think it's strange because x-min is on the left, so why I add something? We add something because the offset is negative. You can change the logic if you want. We can change the signs and put plus and minus here and to invert the signs here if you want. It's going to be the same thing. Let's start it and see what it gives. So now you can see we have the good result. We display the vertical lines and it's stopping at the right position. It's correct. Let's try it in the perspective mode. I go back to my transformation function and I'm going to comment the perspective mode. We have something like that, which is quite good, but you may see that it's a bit strange what we have here. So let's add some more lines to better see what is the problem that we have. Put 15. Okay, let's try that. So it's quite nice, but you may think why this tile is smaller. This one seems to be longer. Yes, so we will need to solve that. That's one of the problems that we have. It's because we have a constant spacing between the different lines here. You may think that this spacing is higher than this one, but in fact that's not the case. If you put your finger on the screen, you can see that the spacing is constant. Here, for example, I can show you. I can measure the height between these 2 points. It's going to be 58 pixels. And if I go between these 2 points, it's also 58 pixels. But to have a good perspective impression, we will need to change that. We will need to update our transform function so we don't have that phenomenon. And we will need to change the spacing between the different tiles so that the spacing is not constant. I'm going to explain you that in the next videos. We have defined the spacing between the different lines and the number of horizontal lines. And then we use our transformation function to display it in the perspective space. But we have this phenomenon that is, we think that the tiles at the front are shorter than the deeper tiles. And this is because we kept a constant spacing between the horizontal lines. We are going to change that to get another result, to get something like this on the right. So we have a kind of attraction to the perspective. The more we go closer to it, the more we get attracted. So the spacing is bigger on the front and it gets smaller and smaller between the different lines. We previously spoke about the factor y. Factor y is a proportional vertical factor. That means 100% of distance from the perspective point, and the more we go closer to the perspective point, the more the factor will decrease. 80% from it, 60% from it, 40%. How can we get something like we have on the right? The idea is to get a factor y that is smaller than expected. That means it's going to go faster to the perspective point. So you may say, yeah, we can multiply it by something that is less than 1, for example, 0.5. So instead of 0.8, we get 0.4. But if we do that, and if we multiply 1 by 0.5, we are going to start at 0.5. So it's only going to make the display smaller. It's not going to make something like this. We want to keep factor 1 for the maximum, but we want it to decrease faster than linearly. So I had the idea to make the factor multiply. So I had the idea to multiply the factor by himself. For example, instead of having 0.8 here for this line, we are going to have 0.8 multiplied by 0.8. And it's going to be smaller than 0.8. And this is called the factor squared. Factor y multiplied by itself. So if I take this first value, I get 0.64. So it's going to be displayed here. 0.6 multiplied by 0.6 equals 0.36. We are going to go faster to the perspective point. It's a kind of attraction behavior for this formula. This formula makes a kind of attraction behavior. And we are going to apply this to our transformation function. This is the compute number 2. How does it work? So we agree that we have perspective y here. This is the maximum value that we can have for the vertical spacing, and it's going to be a factor of 1. I put in yellow the modifications in the transform function. I just rename this variable because we will use it as an intermediate value. So before I call it the try, but now it's a linear y, lin y, because that's the linear proportion of the y value from the screen height to the perspective y. Okay, so we just use it as an intermediate value. But most important is this new line. The factor y is multiplied by himself. Then I get my trx, which is the same thing as before, perspective x plus the difference multiplied by the factor, but the compute is going to be different because the factor has changed, okay? And most important, this new line to compute the try, we start from perspective y, and we are going to subtract, because this is the biggest value, we are going to subtract the factor y multiplied by the perspective y. That means if we are here with a factor of 1, we are going to start from perspective y minus 1 multiplied by perspective y, which is 0. Concerning this second line, I will start from here, perspective y, multiply by the factor of 0.64 on this total height, so it's going to be here. And then we will return these new coordinates. Let's implement that in the code right now. I go back to the project, and we previously saw that we had this strange behavior of smaller tiles here. Okay, let's change the transform perspective function. It's not going to change anything for the 2D display, of course, because we are inside our perspective function. So I'm just going to rename this value linear y, okay, and I'm going to use it here. We have our factor y, in fact. Where is our factor y? It's what we called previously proportion y. So I'm going just to rename this also factor y, okay. Now the new line is going to be factor y equal factor y multiplied by factor y, okay. And I'm also going to compute my try, which is self perspective y minus the factor multiplied by the maximum height. So yes, of course, here you may say we can put 1 minus factor, and the total multiplied by this is going to be the same thing, okay. Anyway, I want to keep like I put on the slide, but it's going to give the same result. And let's try that. So you can see that this time we have this perspective effect. We don't have this previous problem, but also I want to show you something. We can accentuate the attraction, because here what we did is to multiply 2 times factor y, but we can also multiply it 3 times or 4 times if we want. Or we can also use a power function, pow. Power function takes the value and we give how many times we want to multiply it. For example, by 2 times is what we did before. That means this is the same as doing factor y multiplied by factor y 2 times. And we can put, for example, 4 times to accentuate the attraction. Let's try this. So the problem is that the spacing is very high between the horizontal lines, so we can just change it a bit. Horizontal line spacing, let's put 0.1, for example. Okay, so we have something like that. And we can also have more spacing on the vertical lines, for example, 0.25. Okay. So we have something like this. We have a real effect of perspective, which is really nice. We are going to keep it like this, and we continue on the project. Now we want to have this animation of moving forward into the game. How are we going to do that? We are going to change the display of our horizontal lines and we are going to shift them downstairs. That means we are going to subtract on the Y coordinate. When we begin to move forward, then we shift everything down. You can see that this yellow line goes here and that this blue line goes out of the display. And then we continue like this. But you can see that if we continue to shift the line, after a moment we will have no more lines to display because all the lines will be out of the display. That's why we will need to implement a kind of looping mechanism. That means when we shift more than the spacing, than the vertical spacing between two lines, then we go back to the original position. To make this shifting possible, we are going to implement a new variable that we are going to call current offset Y, and we are going to apply this offset to all the Y coordinates of the horizontal lines. We will also need to have an update function that will be called regularly 60 times per second. This is our number of frames, 60 frames per second. And every time our update function is called, we will update the offset to increment it and to have the condition also of the loop. Of course, we can also control the speed of the movement. For example, we can increment per 1 at every update or increment per 2 or 3. So we are going also to define a speed variable. Are you ready? So let's do that right now. I go back to the code and I'm going to create my update function. So I go totally at the bottom here in the main widget and I will create a new function, update function. It's a function that we will call in a clock schedule. So it's going to give us a delta time variable. I'm just going to add a print update. Okay, now we need to call this function regularly. So I'm going to go to the init function here, and after the init of my lines, I'm going to add a clock.schedule interval, and I'm going to call my update function with the time interval. If I put 1, it's going to be called 1 time per second. If I put 10, it's going to be called every 10 seconds. So I want it to be called 60 times per second. So I need to divide the time of 1 second by 60. You have to import clock from Kivy properties. Take care of not taking this one, but from Kivy properties, okay? If I start my program, I can see that the update function is called regularly. Okay, so now what are we going to do in the update function? We are going to call the update vertical and horizontal lines. In case we want to change the coordinates of these lines, we need to update the coordinates. So we will do that in the update functions. We don't need to do this in the onSize anymore. Take care of putting the path here because we don't have code anymore. Why we can do that? Because even if you resize the window, the update function is going to be called anyway. So it's going to be refreshed here. Okay, I'm going to comment the print. Let's just start the program and see that we did not break anything. Okay, the behavior is working fine. I can still resize my window and it's working. So now I want to shift my horizontal lines. In the update horizontal line, which is called regularly now, I'm going to add something. So I go to this function, update horizontal lines, and you see that we compute the coordinates and we have the line Y. And in the line Y, I want to add or subtract something because we will go downstairs. So I'm going to subtract my self current offset Y. We need to define this variable, and the value of this variable is going to evolve in the update function. So each time we will call this update horizontal lines, it's going to have different coordinates. So let's initialize our current offset Y. I'm going to give the value of 0 here, and in the update function, I'm going to increment by 1 this value. I need to use self here. Okay. So if I start my program, what's happening? You can see that it's working, okay? I go back to the 2D mode. Okay, you can see that we have our lines going down. It's nice, but what's happening if I put just a little bit lines here? For example, only 5 lines. You can see that it's going down, and after a moment, I have nothing more to display because all the lines are out of the screen. So I need to do something like a kind of looping, but also the speed is quite low. So I want to change the speed. Let's put 8 lines, for example. So we have something like that, okay? And I want to increase the speed. How can I do that? Instead of adding +1, I'm going to add something else here. And it's going to be a value that I will define as the speed. And let's say we give 4. Okay, then I will increment by self.speed. And it's going to be faster, okay? And if I go back to the perspective mode, you can see that it's also working well, and after a moment I have nothing more to display. Okay, so I go back to the 2D mode and we have to implement this looping mechanism. I want to go back in the past when my offset is greater or equal than the vertical spacing between two horizontal lines. If I go to my update horizontal lines, you can see that the spacing is here between two lines, okay? So I'm going to get this value, and if I'm just using an offset with this value of the spacing, I can just go back upstairs to that value, and it's going to make the illusion of the loop. For example, I can test if offset is greater or equal than the spacing. It's working because the spacing between two lines is always the same. And you may think, yes, but in perspective, it's no more the case. Yes, of course, but the perspective function is called at the end. So we don't care about that. We always do all the compute in 2 dimensions. And the perspective will be called at the end. So for us, the spacing between two horizontal lines is always constant and always this value. If the offset is greater than the spacing, what do? We go back, and it's like we shift from one level, okay? And now if I start my program again, you can see that when I go down, it's putting a line again here. So from this point of view, it's always looping. And if I add more lines and going above the top of the screen, I will not see this phenomenon. So here, if I do, for example, 15 lines, you see that I have the illusion that it's always looping. And it's going to work also in perspective mode, of course. Okay, let's try it. Okay, so it's working well. My screen recording is in 15 frames per second, so it may not look very fluid on the video, but on my computer it looks very fluid at 60 frames per second. The behavior is good. That's all for this video, and let's continue on the project. Our program is working fine, okay? We can move forward in the level, that's nice, but we need to change something very important. Look, in the update function, we have this parameter, the dt, delta time. And I did not explain you why we have this delta time here and how we can use it. In fact, you remember, we said that we want to call this function update 60 times per second. In fact, it's 1/16. In fact, it's going to be called one time every 1/16 of second. But it's not going to be as precise as this, because maybe your computer or your smartphone will be busy to do something else. And when he will trigger the call to the update function, maybe it's not going to be as precise as this timing. And so you may go from 60 frames per second to a little bit less than that, 50 or 30 frames on old machines, for example. But the problem is that in that case, because the update function will be called less regularly, the game, especially in the speed at which we go forward in the level, is going to go slower. And so the game is going to be far more easy to play on older machines. And we don't want that. We want the game to have the same speed in the level, even if we don't have the exact number of frames per second. How are we going to manage that? We are going to use this delta time, which is a precise value. And of course, if finally we spend twice the time that we expected between two calls of the update function, we should go forward twice the time. So this is proportional to the delta time. Let's print the delta time value and see what we have. Delta time, and let's print str of delta time. And also I want to print the expected value, which is 1 divided by 60, str 1.0 divided by 60.0. Okay, let's run this and see what we have. So I expand the window here. Okay, I stop the program and I go upstairs, and I see I get different value of delta time. The reference value is 0.016. Okay, so here we can see that it's almost the right value. That's correct. So the delta time is a time difference with the previous call of the update function. So you can see that it's quite irregular. Sometimes it's a little bit more, sometimes a little bit less, sometimes more, sometimes less. So it's not totally perfect. But anyway, we want to take this factor into account. You see that if I multiply by 60, especially 1 divided by 60, if I multiply it by 60, it's going to be 1. It's going to be around 1 for the delta time. So we can try that. Delta time multiplied by 60, and I'm going to remove the remaining here. Okay, let's try again. Okay, I stop my program, and you see that we have something around 1, sometime a bit above. And as I told you, for example, if you have 1.5, it's like we spend 50% more time than expected. So instead of using this value, save.speed, we are going to multiply it by the time factor. And for us, the time factor is delta time multiplied by 60. Okay, I'm going to comment the print. You agree that normally time factor should be always 1. But in reality, if we spend more time between two update calls, for example, twice the time, let's say 30 frames per second, the time factor is going to be equal to 2. So we are going to add twice the value of the speed because we are twice slower on the machine. So at the end, per unit of time, that means after 1 second, we will make the same progression, whatever the frame per second. So we need to take this time factor into account. Even if I think on your machine, you will not really see the difference here. In fact, it's far better to manage the time to have a consistent game on every devices. That's perfect, and let's move on to the next lecture. For this exercise, I'm going to ask you to add a movement on the horizontal position. That means in the same way of using an offset Y, you will need to use also an offset X to get something that looks like this. So we are going to move on the left or on the right, up to you. Okay, you will add this movement on the update function, and you will need to create these variables, speed X, for example 3, and current offset X equals 0. You need to use this variable in the code. Of course, you will not use it in the transform function, but you need to apply it to the vertical lines and also to the horizontal lines. You will not need to have a loop mechanism because when we will go at the end of the track, it's okay. We will go out of the track, that's not a problem. We do this exercise because later we will manage the press of the keys so that we can move on the left or on the right. I let you do this exercise on your side, and after that I will show you the solution. So I'm going to define these two variables, speed X and current offset X. Of course, if I go to my update function, I need to upgrade my offset. So I'm going to do self.current offset X plus equal to the same thing here, except that it's going to be a speed X. So we have our vertical speed, which is speed, and our horizontal speed. Okay. Now, where should I use that? I should use it to offset the vertical lines. So if I go to update vertical lines, you can see that we compute the line X. So I can also use that to make a plus and put the current offset X. Int here is not mandatory because we already do that in the transform function. Okay, so let's try that. It's almost good. You can see that we have this good behavior, but we also have a problem for the horizontal lines. You see that they are not aligned with the vertical lines anymore. And that's because we need to use also this offset in the compute of the xmin and xmax in the update horizontal lines function. So I'm going also to add this offset here. And this time you can see that if I start my program again, I have the right behavior. So you also see that every time I need to resize my window. So it's a little bit thing I want to add here. You are going to type on Google Kivy window size and you will find this first link on Stack Overflow. and you will see that you have this config set graphic width and height. So you will copy these 3 lines from Kivy config import config. You copy these 3 lines and you put it at the very top of the file here before any other Kivy import. That's important. So graphic width, we are going to put 900 and 400 for the height. Okay, let's try that. Now I start my project. This is working and the window size is good. That's all for the exercise, and let's move on to the next video. For this exercise, we are going to control the horizontal movement by pressing on the screen on the left or on the right. Of course, it's going to be useful for mobile phone, but for the computer, we want to manage the keyboard key press on the left and on the right, but we will do that later. For now, it's just going to be pressing on the screen. Just before doing the exercise, I'm going to prepare some code. First, I'm going to comment this line of code. So we start without any movement. When you will press on the left, you will go on the left of the land, and on the right, you will go on the right. So I'm going to write some functions here to manage the touch on the screen. Def on touch down, then I will not do anything yet. Def on touch up when I release the finger. Okay, so here on touch down, you need to know if you pressed on the left or on the right of the screen. And what you can do, you can look at touch.x, which is less than self width divided by 2. For example, if that's the case, we go on the left. So I'm just going to add a print, okay, with an arrow, and else we go on the right. If I do a touch up, I'm also going to add a trace up. Okay, let's try that. You can see that if I press on the left, I see left, then up when I release my button, and on the right, I can see right, then up when I release. So of course, when you keep the button pressed on the left, you will move to the left direction until you release your button, and on the right, it's going to be the same. And when you release your button, you have no movement on the horizontal axis. That means this line that we commented will sometime add 0, or sometime add a value, or sometime decrease a value, depending on what you are doing here. And for that, you will need to use an intermediate variable. That is going to be the current speed x. And it's going to be 0 as a default. And on the update function, you are going to increment this current speed x self. Okay, so I let you do the exercise right now. You need to give the right value for this variable, depending on what you're doing here with the touch. Do the exercise and then I will show you the solution. So we need to give a value to the current speed x. Of course, if we release the button, we don't want any movement anymore. So it's going to be a speed of 0. But if we press on the left, we are going to give a value here. It's going to be the self speed x. And on the opposite direction is going to be minus self speed x. Let's see if it is working correctly. Okay, I press on the left, I go to the left. In reality, the land is moving to the right, so I have this impression that I'm moving to the left because the spaceship will be always at the middle of the window. Okay, if I press on the right, I go on the right, and if I release, I have no movement. But it's a little bit slow, so what we can do is to improve this speed x by 20, by 12, for example. Okay, so I have a speed on the left and on the right. This is correct, but on the computer, we also want to manage the keyboard, the left key and the right key. So we are going to do that in the next video. That's all for this exercise, and let's continue. Let's add the keyboard management in our project. On computer, we want to be able to press the left and the right key on the keyboard to move in the game in the same way when we press on the screen. If you go to Google and you type Kivy keyboard key, you will find the first link here. How do you check for keyboard events in Kivy? And then you will see an example that we can use. So you can see we get the keyboard here with a window request keyboard. And then we bind the onKey down, that is this function. And we also give a function when the keyboard is closed. Because on mobile, the keyboard can be open and closed, but we will add something after so that we only use the keyboard configuration on computer and not on mobile. This is because on mobile, the keyboard will be displayed on the screen and that's something we don't want. So I will show you how to do that. First, we are going to copy these lines of codes, okay? And we are going to adapt this. So I copy this and I go back to my init function here. I'm going to paste at the end of my init function, okay? But we are going to move the clock schedule at the end of the function. I want the clock schedule to start the update when everything has been initialized. The window, we need to import a window from Kivy core window. Okay, I don't like this underscore before the function name, so I'm just going to change that here and here. We need to register the onKey up also. So I'm going to duplicate this line and put onKey up because we need to know when we release the key. OnKeyboard up prototype of the function, I'm going to copy paste the onKeyboard down, is almost the same as the onKeyboard down, except we don't have the last two parameters. OnKeyboard up, and I'm going to put pass inside. I don't want to manage this key, but I want the left key and the right key, and inside we will need to write our own code, of course, that we will replace in a moment. So I'm just going to remove this, okay, and I have to return true to say, okay, I have managed this key press, and we are going to do the same on the onKeyboard up. Okay, also something I need to add is the unbind of the onKey up here. Okay, perfect. So what do I want to do in this function? The same thing that we do when we press on the screen. So I'm just going to cut these two functions and to paste it close to the onTouch down and onTouch up. On keyboard down, when we press left, we are going to do this current speed equal speed x. And also I will comment the prints here. We don't use them anymore. Okay, so I'm going to do the same thing here. And I will do the opposite here with a minus like we do here. And on the onTouch up, I'm going to put the speed to 0 in the onKeyboard up. Okay, so let's try it. I'm going to start my program. First thing I can see is that my window size is not the one we have specified. So it's something that has been broken here. We are going to have a look at that. But if I press on the left arrow key on my keyboard, on the left it's working, and on the right it's working too, and I can still click on the window and it's also still working. That's fine. So why do I have a problem with the window width? If I go totally up in my file, I can see that this line has been inserted automatically when I wanted to import the window, and I told you we need to do this before any other Kivy import. So I need to move this line just below, and I will keep this. If I restart, you can see that this time my window size is correct. Okay. One more thing I want to add is I don't want to configure the keyboard in the case we are on mobile. So we need to define a function that will say if we are on desktop computer or if we are on mobile. Def is desktop. And for this, we are going to use something that is called platform. So we can do if platform, and you can see that I can import this from kivy.platform. Okay, of course we will check that this is going to be after the Kivy config here. Okay, perfect. Platform will contain the name of the platform we are running the program. That means it can be Linux, Windows, macOS, iOS, Android. So we will check if platform in Linux or Windows or Mac OS X, then we will return true. We will say yes, it's a desktop computer, and in every other case it's going to be false. Okay, so I'm going to call this function here if self dot sorry, I need to add a tab, okay, is desktop. Only in that case, we are going to configure the keyboard. We don't want to do that in the case of mobile, okay? And also I will add a breakpoint here. So we will analyze what do we have in the platform here. I will press on the debugging mode. Okay, so if I put my mouse over here, I have the Mac OS X value. So if I step, it's going to be true in my case, okay? This is correct. I just restart my program to see if it is still working correctly, and I can press my left and right arrow on the keyboard. It's working well, and also when I touch the screen. Everything is working perfectly. That's all for this video. Galaxy project version number 2. At the end of this version 2, the project will look like this. So you can see we have a pass generation. I can also move. And when we detect that the ship is out of the pass, you can see this game over. But the game is still continuing. Also, the speed is very slow here, but it's on purpose. For this version 2, we will first organize and structure our code. We will be able to display the pass. First, we will display one tile, then we will be able to display multiple tiles, and after that, we will generate our pass with the land generation algorithm. We will also display the spaceship and check if the spaceship is still on the track. If that's not the case, we will display game over, but the game will still continue at that stage. Are you ready to start? Let's do it. Before starting, let's clean and organize our code a little bit. Because on the main widget, we have a lot of functions and a lot of code. So I want to separate a bit some functions in some other Python files. And for example, we can move all these transform functions to another file. So you are going to create a new Python file and you will call it transforms. Okay. Now when I go back here, I will take transform 2D and transform perspective, and I will cut that and I will paste it directly in the transform.py. And now you can see that if you try to start the program, it's not working anymore because it says main widget has no attribute transform. So we need to tell the main widget that it has to include these functions. So we need to go inside the main widget. So you can go anywhere inside the class, but not outside. I will just write the code here at the first line inside the main widget, and we will write from transforms, that's the name of the file, import and the name of the functions, transform 2D and transform perspective. Okay, now I can start my program. It's working fine. What else can we move? I want to move all the user interactions, all the keyboards and touch functions. So if I go a little bit downstairs, I have on keyboard down, on keyboard up, on touch down, and touch up. I want to move these functions on a new file that we will call user actions, and I will paste that inside. The same way, I have to import this from the main widget. So from user actions, import keyboard up, on keyboard down, and on touch up, on touch down. I can also move the keyboard close function, okay, and I will paste it at the beginning of the file. I also need to import it, so I go back here and I will add import keyboard closed. Perfect. Let's start again to see if it is still working. Okay, perfect. And before we finish on this video, I want to clean a bit my code, so I will remove some functions that we don't use. For example, on parent, on size, and on perspective point X and Y, we don't use them, so let's delete all these functions. Now that our code is more organized and clean, we can continue on the project. We want to be able to display the tiles in our game, so how are we going to do that? Here I display the vertical lines, for example, 4 vertical lines and 4 horizontal lines. Let's say that if I want to display this tile, we will say that this one is a tile 0. And the one just on the right will be the tile 1, 0. It's going to be a coordinate system with X and Y for the tiles. So this one will be 0, 1, this one -1, 0, 2. And this is what I call the tile index, TIX, TIY. And it will be useful to have a function get tile coordinates that takes this index and that will return the actual X and Y coordinate of this lower left point. Because if we have this lower left point, we can also have the upper right point if we give the +1 X index and +1 Y index here. So from these two coordinates, it will be easy to draw the tile on the screen. To implement this function, we need to get the coordinates of the different lines. And for that, we are going to assign some index to the different lines. For example, this line, we will say that it is the line 0. This one, the line -1. This one, the +1 and the +2. Of course, if we have more lines, we will have the -2, -3, +4, etc. Concerning the vertical lines, it's going to be the same. Line index 0, line index 1, index 2, okay? First, we will get the X coordinates of the different vertical lines, and we will write this function, get line X from index. For example, if I give index 0, I'm going to get the X coordinate of this line. If I give index 2, I will get the X coordinate of this line. And after, we will also implement the get line Y from index for the horizontal lines. And this will make it far more easy to implement the get tile coordinate. And also, we will use this new function to rework the code inside update vertical lines and update horizontal lines. So how can we implement this new function? Here you can see we have the central line X and we have the spacing between two different lines. The spacing is the V lines spacing multiplied by the self width. If I have an index of 0, you can see that I'm not aligned in the center of the screen, but I'm halfway on the left. So we will compute an offset that will be index -0.5. So the line X will be the central line X plus the offset multiplied by the spacing. If I have the index of 0, I have the offset of -0.5. So I start from my central line X, and then I go left 0.5 times of the spacing, and I arrive here. If my index is -1, I will have the offset of -1.5. And that if I start from the central line X, I am at -1.5 the spacing. Okay, and we also need to add the current offset X, which is the global offset when we press on the left and right keys. Let's go back to the project and let's implement this new function. I'm going to write this new function just above this update vertical lines. Def get line X from index. And so we have this index parameter. I will take what we did here, okay? We have our central line X that we compute from the center of the screen. Finally, I think it would be better to take the perspective X because perspective X is also at the middle of the screen, but it will allow us maybe later to change the position of the perspective point. So it will be better to write here self.perspective point X. Okay, we have the spacing, and for the offset it's going to be different. It's going to be index -0.5. When the index is 0, I want to be halfway on the left. So my line X will be central line X plus the offset multiplied by the spacing and also plus the current offset X. So we have our offset when we want to go to the left and the right when we press the keys. Okay, and I will return this line X. Of course, I can rework my function here. So I can delete all of that and I will get the line X from the get line X from index here. Okay, so I don't need to use offset anymore here. So what is the index I have to pass here? You can see that we have to rework this. And the minimum index should not be 0, else we will see lines only on the right. But it should start halfway of the number of lines. For example, if we have 4 lines, we'll have -1, 0, 1, and 2. So we can compute this start index, which will be here. Okay, start index is going to be the half of number of lines. I'm just going to put int. Okay, so if I have 4, I'm going to get 2 for the start index. So I will put -2, but in that case, you see that we don't start at -2, we start at -1. So I need to put plus 1 for my start index. And what is my end index? End index is going to be the start index plus the number of lines. So for example, here the start index is -1. The number of lines is 4 minus 1 equal 3. So I will get 3 for this value here. But that's correct because in the range, we will never reach 3 for the I. We will reach 2. So we will have this. It's going to work if we give from index I. Let's try it. Okay, so it is still working fine. I just want to simplify a bit the program here. I want to go to the transform and enable the 2D transform so we can really see what we are doing here. And also we are going to disable any movement. So I'm going to comment the offset Y and the offset X in the update function, just for the time that we are working on the coordinates for the tiles. And also I will put less vertical lines. I will put 4 vertical lines and 0.1 for the spacing. Okay, so now I have something like this. It's correct. And also I can update the update horizontal lines because we copy paste what we did previously on the update vertical lines. So we can delete that and we are going to compute xmin and xmax from the new function self.get line x from index. Okay, the start index, we have it. It's this value, the line totally on the left. Okay, so I can put start index here, and for the end index, it's going to be the start index plus number of lines. So for example, I have number of lines 4, start index is -1, so it's going to be 3, but the maximum index I want here is 2. So I need to put -1 in this case. So I have my end index here. Okay, I can restart my program and everything is working fine. For this exercise, you are going to implement this function, get line Y from index. So if I give index 0, it's going to return 0. If I give index 1, it's going to be spacing Y, and then index 2, it's going to be the Y value for this line, etc. Okay, and so on. Don't forget to use the current offset Y. And also you will need to rework the update horizontal line function to use your new function. I let you practice on your side and then I will show you the solution. Just below this function, I'm going to implement the new function, get line Y from index. Okay, if I go to update horizontal lines, you can see that we have here the spacing Y and that we have already this computation of the line Y. So I'm just going to copy these lines and that I'm going to paste that. Okay, spacing Y equal H line spacing. That's the distance between two horizontal lines. That's correct, multiplied by the 8. Okay, I'm going to delete the 4. And then the line Y is the index multiplied by the spacing. Okay, if we have index 0, we will start from 0, minus the current offset Y. You remember that this is the offset that we use so that we have this illusion that we go forward into the game. And then I return line Y. Now I'm going to use this function from the update horizontal lines. I will replace this line of code with self.getLineY and I will pass the index. I don't need the spacing Y anymore, so I can just clean it from the code. Let's start the program to see if it is working well. Everything is correct. That's all for the exercise. Let's display our first tile. How can we do that? For example, if you want to display the tile 0, we need to first implement this getTileCoordinates function. So we can get the lower left coordinate xmin and ymin. If we pass to this function +1 and +1, we are going to get the xmax and ymax. So it's going to be easy to be able to display this tile. Concerning the canvas, are we going to display this with a rectangle? Not really, because in the perspective mode, we will need to display something like this. So we will need to give 4 coordinates. And for that, we are going to use the quad. It's not possible with a rectangle because the rectangle uses a width and a height only. Here with the quad, we will give 4 points. How does the quad works? So we have our x min, y min that we get from the get tile coordinate 0 in that case. If you want to get the x max, y max, we get it from +1 and +1. Okay. You can see that we have also 2 other points, x min and y max, and x max and y min. We need to give the 4 points to the quad. So the quad will get a points list. In which order does we need to give the points? That's up to us, but we need to rotate in a way or in the other way. But we cannot go from that point to this one or something like this. We need to take a point and rotate. So in our case, this will be point number 1, number 2, number 3, and number 4. So at first we will put x min, y min, then this one, and then x max, y min. Of course, we will need to call our transform function at the last moment. That means we will need to use intermediate variable like x1 and y1. So x1, y1 will be the transformation of x min and y min, and so on. Let's implement this and display our first tile. So first thing I'm going to do is to implement this get tile coordinates function. So if I go just below that, I'm going to write def get tile coordinate, and it will take the tile index x and tile index y. I need to return the x and y of the tile. So x is going to be finally the get line x from the index tix, and the y, it's going to be the get line y from the tile index y, and we need to return this. Okay. For this first example, we are going to display only one tile, but of course in the game we will need to display multiple tiles. So let's just define only one tile for now. So I'm just going to write tile equal none, and we are going to give the coordinates here. Tix equals 0. Of course we will change that later so we can check if the different positions are working well. Okay. Then I will do the same principle as the vertical and horizontal line. I will have an init function. So self init tiles, and I will have an update function. For init tiles, I'm going to copy paste the init vertical lines function. So it's going to be init tiles, and I don't need to do that. Okay, I will display it as white, it's correct. And here I will do my self tile. It's going to be the quad, so I just write quad, and I need to import it. Okay. Then I will do my update function. So I go a little bit downstairs, update tiles. Of course, I will need to call this function in the update function. So I will just do it right now. Self.update tiles. Okay, I go back here. I want first to get my x min and y min. How can I get this? I can call self.get tile coordinates, and I can give the coordinates of my tile, tix and tiy. Okay. Also, I can get the x max and y max by putting a +1 and +1 in the index. Now I want to give the points to my tile, to my quad. So it's going to be points equal, and I'm going to give the list of points I'm going to have here. x1, y1, then x2, y2, then x3, y3, and 4. Okay. So I need to compute all of this. x1, y1, it's self.transform. And you remember that the first point, I'm going to put a comment here, is going to be the one at the bottom left. And then the second one is at the top left. And then we get third point and the fourth point. So this one, it's x min and y min. And I'm going to copy paste this line for 3 times. So we have 2, 2, 3, and 4. Okay. Point number 2, x min, y max. It's upstairs. Point number 3, x max, y max. And point number 4, x max, y min. Okay. So I will give all of this. Let's try it and see what it gives. Okay. My tile at 0 is displayed here. That's correct. Let's change the coordinate. So if I go here, I will give x equal 1, for example. Okay, we can see it's correct. It's displayed at 1, 0. And I'm going to display at 1, 2. Okay, 1, 2. It's correct. Let's go in the perspective mode to see if it is still good. Okay, I can see it's still 1, 2. Everything is correct. And we move on to the next lecture. We are able to display our tile correctly. Now, if I enable the animation again, is it still working correctly? So let's try it. I go back to my update function, and here I will enable the Y current offset Y. And here I will uncomment this line with the current offset Y. Okay, we can keep this line commented for now, but here we will go forward into the level. And also I will change a bit the speed here. I want to have a speed only of 1 so we can see what's really happening. Let's try it. You can see that my tile is going back after a moment. Every time we loop, every time the line is coming here at the bottom of the screen, we have this loop effect. And this is because you remember in the update function, we have this looping mechanism. So the horizontal lines of the level are always displayed. When we reach the spacing between two lines, we go back to the initial position. And in fact, the position of my tile is always correct. It's always 0, X and 2 for the Y. So how can we make the tile going forward? Every time we loop, we need to remember that we loop. So we will have a loop index that we will call the current Y loop. And it's going to be +=1. I'm going to declare this variable. So here, current Y loop equal 0. Okay, so you can see that if I add a print loop, and I can display the value of this loop, and I can put it on the screen. Okay, so you see, every time we loop, the tile go back in the screen. So what we are going to do is every time we loop, we are going to change the index of the tile on the Y-axis. Initially, our tile is on index 2 for the Y, but then when we will first loop, it's going to go to index 1, then index 0, and so on. So we need to subtract the index of our tile from the current loop. We already have a function that returns the coordinates of the tile. It's getTileCoordinates. So I can look at this variable inside this function, and we will use it to offset the index of the tile. TIY equal TIY minus the current Y loop. So the first time we will loop, the loop will have a value of 1. Then we offset the index. So here we do the index -1. So the tile will not jump again, but will go to the next line. Let's start the program again. And you can see that this time, every time I loop, my tile is evolving in the level. And it's working perfectly. Let's write some code to display multiple tiles. How can we do that? We need to change this part of code because here we manage only one tile and we put some coordinates here. So we are going to change that and to have a collection of tiles with a list here. So tiles is going to be the list of the quads. And we also need to have the number of tiles, for example, 4 tiles. And also we need to remove these coordinates because the different tiles will have different coordinates. So we need to have a list of coordinates, tiles coordinates. Okay, we will write a new function to generate the tile coordinates. But at first it's going to be a very simple generation. I want to generate the tiles in the middle of the screen. So the first tile will be at 0. Then the second one will be at 0, 1, 0, 2, and so on. It's going to be a straight line in the middle. And of course, later we will change that generation function so that we can generate the land of the game. Okay, so let's write the code. First, I need to change my init function because I need to loop on NB tiles to initialize the different quads. So I go to inside init tiles, I need to loop here. So for I in range 0 to self NB tiles, I will create quad, but I will add it in my tiles list, tiles append quad. Okay, and I need to be inside the loop. Of course, we will need to rework the update function because we need to use the tile coordinates. But first, let's generate the tile coordinates. I will write a new function, def generate tiles coordinates. I will use the same loop on the number of tiles, and inside the tile coordinates I will append some coordinates. Inside this list I need to append some tuples, so inside the parentheses I'm going to add more parentheses. For this first generation it's going to be very simple. All the x index is 0 and the y index is going to be I. So the first tile will be at 0, then the next one at 0, 1, 0, 2, okay, to build this straight line. Of course, I need to call this function at the beginning. So I'm going to copy that and to paste it here. Self.generate tiles coordinates. Okay, just below init tiles. Next thing we need to do is to adapt the update function. Update tiles. Previously we used this variable. TIX and TIY. Now we need to loop and update the points for every tile. So again, I need to loop on I in range 0 to NB tiles. Okay, and I will put everything inside the loop. My coordinates are in self tile coordinates of I. And you remember what we did? We put a tuple for each tile. That means for each coordinate, the index 0 is the x and the index 1 is the y index. TIX, TIY. So in my tuple here, I will call it tile coordinates, local variable. And here I will get the x from the index 0 of my tuple and the y from the index 1 of my tuple. And to get the x max and y max, I will do the same plus 1. Okay, now I need to update the tile. So it's going to be in the tiles. I can do the same as here. I will say that my tile is a self.tiles at index. Okay, so tile.points equal all the points. Let's try it. Okay, so you can see I have 4 tiles displayed in a straight line. And of course I can change the number of tiles. For example, I can put 8 and it's going to generate more tiles. Everything is working correctly, and let's move on to the next video. Let's improve this function to generate infinite tiles. So now we are just going to keep the straight line, but you can see that after a moment the straight line disappears because we have a limited number of tiles. So what we are going to do is that all the tiles that are no more visible, that are out of the screen, we are going to clean them from the tile coordinates, and that will make new space to add new coordinates that we will add after. So we will make a mechanism to generate new tiles on the fly. For example here, if I reduce the number of tiles to 4, and when we will implement this solution, you will see that new tiles will appear after each loop, so we will generate this straight line an infinite way. How can we do that? You remember that in the update function we have this loop indicator. So we will compare, does the tile index y is less than this loop? Then we will clean it from the coordinates. And of course we will need to call our generation function each time we change this variable. Now the generation function has been done in a way we should only call it at one time in the init, but we will change it so we can call it in the update function every time we increment the loop. So first thing we are going to do is to clean the coordinates that are out of the screen. And the condition is that the tile index y, so this is what we have in the tile coordinates at 1, and the condition is that the tile index y is going to be less than the self current y loop. Okay, when I increment this variable, it means that the tile that was at 0 is already out of the screen. So at the next call of this function, we are going to clean it. Let's implement that, and then we will debug to see if it is working correctly. So we are going to loop on this tile coordinate, and because we are going to delete some elements inside this list, we are going to start from the end. So I will write for I in range. What is the end is the number of elements in the list minus 1, else we will be out of the list. Okay, and then I will put -1 here because I want to decrement. I will start from the maximum value and go to the minimum value, but for the minimum value, we also want to go to the 0 index. And because in the range we will never reach the 0 here, we need to put a -1 so that we can reach 0. Okay, the condition is that if tile coordinate at the index and we select the y, it's less than the current while loop, then it disappeared. It's out of the screen. So in that case, we will just delete it. Okay. And because we will call this function again and again, we should not start from 0 every time and append many coordinates. We should look how much space we have left in the tile coordinate. So we are going to start not from 0, but from the number of elements. Okay. Of course, the first time it will be 0. So first time we will fill everything. And I'm going to put a print foo so we can have a breakpoint here and we will see what happens. Of course, this function, we need to call it again every time the current while loop changes. So it's going to be called one time at the beginning to generate the first 4 coordinates. Here, this code will not do anything because at first current while loop is 0. And of course, we don't have any elements in tile coordinates. So we are not going to do anything here, but here the length of tile coordinate is 0. So we will append all the elements at the first call. Then for the next call, we will see what happens. So I will need to call it in the update function just after we have updated the current while loop. Generate tile coordinates. Okay, let's have a look and let's put a breakpoint. I will have foo1 and foo2. Foo1 just after the deletion of the elements and foo2. Okay, so let's have a look at what we have in self-tile coordinates. At the beginning, we don't have anything. Okay, if I press continue, then we generate the elements and we have our 4 elements, 0, 1, 0, 2, 0, 3. It's correct. And we have the current while loop, which is 0. Then I will continue the execution. We enter the function again. We did our clean with current while loop equal to 1. So now what we have in the list is only 3 elements because we remove the 0 in the y is less than current while loop, which is now 1. Okay, but now what's happening? We want to generate a new element because we have 1 space. So we want to add a 0, 4. And look what will happen here if I step. I'm going to add 1 element because I have the space to add 1 element. But I'm going to add the element at the index I, which is not the right value, which is 3. So here I will add again the same tile. And what I need to do is to have another variable, which is going to be the last y. So we are going to look in the list what was the last element, and we are going to take its y, which is 3 in that case, and add a +1. And then we will add the 0, 4. And every time we will take the last one and make a +1. So we can continue the generation this way. So let's do that. Let's say that at first, the last y is 0. When we start and when we don't have any elements, it's going to be 0. That's what I'm going to use here instead of the index. And of course, I need to use last y plus equal 1. Okay, but that's not enough. For the first time, it's going to work. And when we remove 1 element, and in that case, it means in that case, we want to take the last element and takes its y value +1. So let's do that. If we have some elements, if the length of tile coordinates is greater than 0, then we are going to take the last coordinate, which is in Python at the index -1. Okay, and last coordinate is going to have the x value and the y value, and we are going to take its y value in the last y, but of course we need to add a +1 so that we can generate the next tile. Okay, let's put again the breakpoints and try it. Okay, again the first time we did not generate anything yet. Tile coordinate has nothing. I press continue, then I generate my first tiles. Okay, let's continue. This time I clean the first one and I got the last y, which is 4, because I took the value 3 +1, so I get 4. And now if I step, I'm going to add the 0, 4. And then next time it will be the 0, 5, 0, 6. So I will have an infinite line. Let's continue the execution And you can see that the way is generated automatically and infinitely. Let's generate the land for our game, and we want to generate a random path. Now we just generate a straight line, but we want something that goes on the left or that goes on the right. So how can we do that? For example, if I get a random number, and if I say, okay, we always get an x of 0, but if you want to go on the left, we will get an x of -1 or +1. So let's try to get a random number that is between -1 and +1. If I type r like random equal random dot rand int, you need to import random this one. We will put the minimum value of -1 and the maximum of +1. Both value can be returned in the result. It's included. Okay, so I will put this value as a r, and let's see what it gives. You can see that I have a kind of land generation, but we don't get really a path. So it's not going to work well with a ship because, for example, we cannot go from here to here. It's going to be a game over. And of course, we need to share more than just a corner between some tiles. So we will need to add some more tiles to make a real path. So for example, what we can do is to choose what we want to do. For example, go forward. It's going to be this first choice, just to add a tile, and that's what we are doing here. If we go on the right, it's going to be this tile that we use to go forward, the same one, then a next tile on the right, and then a next tile forward. So it's going to be this pattern, okay? And then we can continue. And if we want to go on the left, we generate one tile forward as usual, and then one tile on the left, and then one tile forward. So we will have also this pattern. What we are going to do is to get a random number, 0, 1 or 2, and depending on the value of this random number, we will generate a different pattern in the coordinates. But you can see that for every pattern, we still need to generate the next tile, the one that goes forward. It is common to all patterns. In the case we go on the right, we'll generate this tile on the x and y, then on the x plus 1 and y, and then on the x plus 1 and y plus 1, okay, and so on. So let's do it. Let's say that when we go forward, it will be 0, when we go on the right, it will be 1, and on the left, it will be 2. So let's implement this solution. I'm going to get a random number between 0 and 2. In all case, I will need to generate that one. Of course, it's not r, it's the last x. We need to manage the last value of the x to continue the path. So in the same way that we have the last y, I'm going to have my last x equal 0. And we will also get it from the last tile. Last x is going to be, we don't need to use +1 for this one because we keep the same x. And we put 0 to get the x coordinate. Okay, now I want to test. If r equal 1, I will go on the right. Let's put a comment here. So let's say that 0 is straight, that 1 is on the right, and that 2 is the left. So if r equal 1, then we need to generate a next tile that will be just on its right. You remember the pattern? It's like this. We have the tile, then we have this next tile close to it, and on top of that we will have the next one. So I need to get the last x plus equal 1. And then I will need to generate the one that goes forward. So I will need to have the last y plus equal 1 and generate my tile. Okay. In the case of r equal 2, I do a last x is -1. And I will do the same thing. So let's try it. Okay, I have a land generation. It's quite slow. And also what I want to say is that previously is that in this loop, we look how much space we have in this tile coordinate. For example, if we already have 3 coordinates and we have a maximum number of tile of 4, we will have only 1 space. But before we used to only happen 1 tile in every loop. Now it can happen we add 3 tiles and that we go above the number of tiles. But it's okay. We will just have more coordinates here than the number of tiles. But anyway, when the old coordinates, the one out of the screen, will be cleaned, we will make more space. And because we check the length of tile coordinates, Yes, it will happen that this value will be sometimes greater than the number of tiles, but it's okay, because on the update function, we just loop on the number of tiles and we will just ignore the extra coordinates. So we can do that, but we need to speed up a bit the game, and let's say we put 4, and also because we need to display more tiles, I'm going to put, for example, 8 here. Okay, so now we have really a land generation, which is interesting because we have a pass. Of course, we have this effect of generation. So if you don't want this effect, you add more tiles, for example, 16. And this time you will not see the generation because it's going to be done very far. So we have two issues, because you can see that the land generation can go totally out of the track. So we will need to solve that. And also, when we just start the program, it will be nice to have first a straight line and after begin the land generation. Else it's going to be too difficult for the player. Also, I want to try by enabling again the keys. So I'm going to uncomment this line to be able to go on the left and on the right to see if everything is working well. Okay, I can go on the left and on the right. We really have a beginning of a game here. That's all for this video, and let's continue on the project. You can see that the land generation can go out of the grid here, and I'm going to ask you for this exercise to make it impossible. But first, let's change a bit the parameters, because the grid with only 4 vertical lines is not interesting for the game. So we will put 8 and we will put more spacing, .2. Okay, let's try it again. So you can see that sometimes the land generation goes here out of the grid. And I want you to solve this problem. How to solve this? You remember that in a function on the update horizontal lines, we have this start index variable and end index. It gives the index of the line totally on the left and the line totally on the right. So you will take these two lines, you will copy that in the land generation, and you will compare to your last x. If your last x is already less or equal to the start index, then you will need to go on the right because you are already too much on the left. And to go on the right, you will force the value of the random value. You will not take the random value, but you will override it to go on the right. And here you will do the same to go on the left. I let you do the exercise and then I will show you the solution. So first thing I will do is to take these two lines and go back to the land generation in the generate tiles coordinates. When I get the random value here, I will first have a look. Okay, does my last x is less or equal than the start index? That means I'm already totally on the left. And in that case, I will not take this random value, but I will say go on the right. So I will force the value of 1. On the other side, if my last x is greater or equal than the end index, that means I'm too much on the right. I will go back on the left. So I will give value 2. Let's try it. Okay, you can see that here I reached the maximum, but I did not go over. And you will see that even if you wait for a while, you will never go out of the grid. And that's all for this exercise. We are going to improve our game by adding first a straight line, and after a moment we will really begin the generation of the pass. Else it's going to be too difficult for the player if we start directly with a pattern. So you will add this straight line of 10 tiles, and after that you will begin the generation. For this you are going to create a new function that I will call pre-fill tiles coordinates. Okay, you will implement this function and you will add 10 tiles in a straight line. Of course I need to call this function. We will call this function only one time in the init and just before the generate tiles coordinate. I let you do the exercise and then I will show you the solution. So here I will loop for I in range 0 to 10 and I will add some coordinates. In self tile coordinates at the beginning, this list is empty. So I will just append some coordinates inside. I need to put my tuple, so it's going to be parenthesis inside parenthesis. Because it's a straight line in the center, we use 0 for x and we use I for the range. And we use I for the y. So here I will get 0, 1 until 0, 9 straight line. And after that, we will get some code to generate tile coordinates. At first, it will not generate anything because we already have too much coordinates. We are already over the number of tiles. But after a moment, it will remove some coordinates that are no more displayed on the screen. And when we will have more space, then we will begin to generate new tiles. Let's try it. You can see I have my straight line, and after a moment, I can begin to play. Everything is correct for this exercise, and let's continue on the project. Let's display our spaceship on the screen. The spaceship is going to be a triangle, and we will place it at the bottom and center horizontally of the screen. Self.width divided by 2. We will define new variables to define the width of the ship in a percentage of the screen width, also the height and also the base y, so that it is not totally at the bottom of the screen. Concerning the canvas, we are going to use the triangle instruction. We will need 3 points, point number 1, number 2 and number 3. For this exercise, you are going to implement the coordinates of these 3 points for the ship and to add it in the new ship variable that will be our triangle instruction. First, we will write some code together and then you will do the exercise. I'm going to define the new variables. So I go at the top of the main widget. And here I will create the new ship variable that is none and that will contain the triangle instruction. So we will need to create an init ship function. Also I will define the ship width that is going to be 10% of the screen. So I give you some values that I tested previously that makes the display nice, but you can change them of course. Ship height, which is 0.035 and the ship base y equal 0.04. Okay, let's create the init ship function. Init ship, we want to use the canvas, and this time we are not going to use a white color because the ship will be displayed in black, so we will put 0. And of course we want to create our triangle instruction, and this is going to be saved in our ship variable, and we need to import that. Okay, now we need also to create the update function. So you may say, yes, but the ship is not moving. It's the land which is moving. Yes, but the ship is displayed at the middle of the screen. Because we can resize the window, the middle of the screen may change. So we need to update the coordinates of the ship. Def update ship. And this is what you will need to do for this exercise. You will need to compute the coordinates, and at the end you will do self.ship.points equal x1, y1, x2, y2, x3, y3. And you need to give these different value, x1 equal something. From the slide, you remember that point number 1 is the lowest left and point number 2 is here at the center. And then we have point number 3. Don't forget to use the transform function, because here we display on the screen. So you will need to call this self-transform. To help you, I'm going to give you some intermediate variable. Center x is self.width divided by 2. Base y, which is the y coordinate for the point 1 and point 3. It's going to be self.ship base y multiplied by self.height. And again, we don't give pixel dimensions for the ship, because if the screen is bigger, then the ship will look very small. So we need to give percentage on the width and the height of the screen. You can also have the ship width, which is going to be self.ship width multiplied by self width. But in fact, what is going to be interesting for you here is to have the half of the width. So we will write ship half width, and we are going to divide this by 2. It's time for you to do this exercise, and then I will show you the solution. So we may write x1 equal center x minus the half width of the ship, okay? And then we will have y1 equal the base y. But take care, because we need to call the transform function. So what we need to do here is to call it from here, transform. And so I'm going to give the x coordinate and the y coordinate, okay? So I can do the same for the other points. I'm going to copy paste this, x2, y2, x3, y3. For x2, it is at the center x. And for the height, we take base y and we need to compute the height of the ship. So it's going to be ship height equal self ship height multiplied by self height. So it's going to be base y plus ship height. And for the last one, it's going to be the same as the first one, but we do a plus on the half width. Let's try it. We see it's not displayed. And why it is not displayed? Because we did not call our functions. And let's call the init function. Should we call our init ship function before the init tiles or after the init tiles? In fact, it is very important, because if we call it before, the ship is going to be displayed under the pass, because the order of instructions matters here. So we need to display the ship after init tiles, so the ship is above the pass. Self.init ship. Okay. Also, we need to call the update function, update ship, that we will call in the update function here, just after update tiles. Self.update ship. Okay, let's try it. You see that this time it's working. We have the ship displayed. Of course, we will need to adjust all the speed of the game, because now it's not really playable. But that's it for the exercise, and let's continue. Maybe you saw that we have a big issue in our game. Look, if I start it, if I resize the window, especially if the window is very small, the game is faster. And if I get the window bigger, the game is very slow. So why do we have this problem? For this exercise, I'm going to ask you to investigate and fix this issue. I give you one hint. It's not a problem of performance. It's really a problem in our code. So try to investigate and at least try to find where does it come from. And then try to fix this problem so that the speed is constant when we resize the window. Practice on your side, and then I will show you the solution. So clearly, why do we have a difference when we change the size of the window? And what defines the speed of our game? The speed of the game is defined by this variable, speed. This is the speed on the y-axis, and also the speed x on the x-axis. So for example, here we have a speed of 4. Where do we use it? We use it every time in the update function here. It means that every time we display a frame of the game, we increment our y by this constant value. And also we multiply it by the time factor, but this is okay. So why is there a problem here? Because we have a constant value for the speed of 4 in this case. And 4 is a very big value for a small screen. That means for a small screen, we increment the y of 4 every time. But 4 is a very small value for a big screen. So that's why we have a difference here. It's because the speed does not depend on the size of the window. And that's what we are going to change. We need to make the speed depend on the size of the window. Because this is the speed on the y-axis, we need to multiply it by the height of the window. So let's do that. We are going to define a new variable, speed y, equal to the speed multiplied by self height. And you may say, yes, but 4 multiplied by the height of the screen, it's a big value. Yes, of course, we will need to adjust the value of the speed variable. And we will need to put something very small. So let's take this and multiply by time factor. Okay, we have to do the same for the x. So speed x is going to be the current speed x. And you remember that current speed x is in fact speed x, but it depends. Sometimes it's speed x or sometimes it's 0, depending on if we press on a key or not. So it's going to be current speed x multiplied by self width Okay, so now I go back upstairs and I'm going to put very small values here and see what it gives. Okay, so for the y, it's going quite quickly, and for the x, it's a bit small. Also, what we can do here is that we can multiply by 100. So we will have 1 and 1. It's going to be more relevant value. So what we can do in the formula downstairs is to divide by 100. Speed y divided by 100 and speed x divided by 100. That means my value here has to be multiplied by 100. So I have 1.0. I said that the speed on the y-axis is a bit high, so I'm going to put smaller value, 0.8, and for the x we need more speed, 3, for example. Let's try it and let's expand a bit the width of the tiles, 0.4. Okay, so we have something like this. You can see I can clearly play in the game. It's a bit difficult, but I can play it. Can I still play it if the window is smaller? You can see that the speed is still the same and I can continue to play my game. Okay, if I expand the window, it's going to be also the same speed. So we fixed our problem and that's all for the exercise. Let's detect that the ship is still on the track. And if that's not the case, it will be game over. At first, we will just print game over. To know that the ship is still on the track, we will say that at least one of the 3 points of the triangle is going to collide with one of the tiles. I'm just going to put a very small speed for x and y and to show you what it gives in 2D. So let's go back in 2 dimension and let's start the program. Okay, I will also reduce the spacing here between the vertical lines. Okay, we have something like this. And what we want to do is to look at the 3 points of the triangle. If at least 1 point is still on the track, it's okay. But if the 3 points are out of the track, it's going to be a game over. But now we are going to print in a loop game over. And later we will implement a proper game over. So do we need to test all the tiles? No, we just need to test the tiles that are at the bottom of the screen because the spaceship is always at the bottom of the screen. So we will just test the first 2 ranks here that are defined by the current while loop. So we will test current while loop +1. And of course, if at least one of the tile makes a collision, what I call a collision is when one of the 3 points is contained on a tile, at least only one tile is needed to say it's okay, we are still on the track. So let's do that. And first we will implement a function to test if the spaceship is colliding with one tile. And after that we will make another function to make the test for different tiles. Okay, so I will just write my function just under the update ship. And it's going to be def check ship collision with tile. And I will give the tile index x and tile index y. You remember that we can get the tile coordinates from this function self get tile coordinates. And I give the tix and tiy. And I will get the x min and y min. And if I want to get the max, I can just add a +1. So I'm going to do like this, +1 and +1. Okay. So now I want to get the coordinates of the spaceship and we have 3 points. So I need to get a new variable to store the different points of the ship. And we are going to call that ship coordinates equal, and it's going to be a list of 3 points that I will initialize here. First point, second point, and third point, ship coordinates. Where do we have the ship coordinates? In the update function here. So we are going to change a bit what we do here to store the different coordinates. And of course, we want to get the coordinates before the transform. After the transform is just for the display, but before the transform is for the logic. And of course, the coordinate we get for the tile are before the transform. Very important. So here, what we will do is self.ship coordinates. For the first point, we want this tuple containing this value for the y. And because we don't want to do a copy paste of the same code, I'm going to use this value here. Now, if I copy that, it's not going to work like that because the transform function needs 2 arguments, x and y. And this is seen as only one argument containing a tuple, as one argument which is a tuple. So we need to expand the tuple. So I will put a star, and this is going to put directly this first argument and this second argument. Okay, let's do the same for the two other points, 1 and 2. This one is center x and base y plus the height, and the last one is the same but just a plus on the x. Okay, so let's copy paste all of this and we do 1 and 2. So check that your index are correct here. Okay, so now we have our 3 points in ship coordinates, and I'm going to loop for these different points. For I in range 0 to 3, I will loop on ship coordinates of index, and I will get the point x and point y. Now I need to see, does my point is inside this tile? So I can check if it is contained. And if that's the case, I will return true, and I will say, okay, we are colliding. I just need at least one point that is colliding. When it's the case, I will just exit the function and return true. But if we loop for all the points and we did not collide with anything, we will return false. So how can I test that? My x must be contained between x min and x max. So I'm going to write my point x must be greater than the x min, and it should be lower or equal than the x max. Also, I can simplify this expression to write it like this. My point x is between x min and x max included. And we are going to have the same for the py is contained in y min and y max. If that's the case, we return true. Yes, we are inside this tile, and we are not going to continue the loop. Even if that's the case for the first point, the function returns true and we exit the function here. Okay, if that was not the case, we continue to the next point and the next point, and if that was not the case for every point, we will return false. Okay, now we want to do that, but for all the tiles that are on the 2 first rank. So we can write our function check ship collision. Okay, this function will return true if the ship is on the track, and it will return false if that's not the case. In that case, we will say game over. Where are the tile coordinates? It's in self tile coordinates. Okay, so what I can do is to loop on these coordinates in range 0 to length of this. But I told you we are not going to test all the tiles. It's not necessary. So we will add an exit condition here. But first, let's get our tile index x and tile index y from the tile coordinates at index. Okay, I get my tile. What is the exit condition? If my tile index y is greater than the current y loop plus 1, it means I don't need to test the tiles that are above the first 2 ranks, because the ship is always at the bottom of the screen anyway. So this will avoid that we do unnecessary tests. If my tile index y is greater than the self current y loop plus 1, because I want to test the first 2 ranks of tiles. If that's the case, I will say that I return false. I could not return 1 because I did not return true, because it means I did not return true on the previous tiles, the tiles that are in the first 2 ranks. Now I will check my tile. If check ship collision with the tile that we want to test here, if we have a collision, then it's okay. Everything is finished. We return true. That's okay. We are still on the track. But if we loop and we test all the tiles and we go after the first 2 ranks, then the story is finished. Or if we go at the end of the function, it means we did not collide, and that's a return false. Let's call this function on the update function. So we go to the bottom of the code in the update function, and then I will call this at the end. Self check ship collision. If we return false in this function, that means we are in a game over condition. So for now, we will just print game over. Okay, let's try it. Okay, you can see I'm on the track, everything is fine. Here I am still on the track because I have 2 points colliding still. Here I have still 1 point colliding, but if I go totally out, we can see game over. Okay, if I go back, it's still working fine. So let's go back in perspective mode to see that everything is okay. Transform, I go in perspective mode, and I'm going to put back some better value here. So line spacing 0.4 and speed X a little bit greater, for example 3. Let's try that. It's far too slow. I'm going to have 0.8. So now you can see it's good, and when I go out of the track, we can see game over here. Okay, everything is correct, and let's move on to the next lecture. Galaxy project version number 3. Our project will look like this. We will have a menu. We will be able to start the project, to play, and to go into the game over. Also, we have the score that is displayed here. In this version, we will first manage the game state. The game will not start by itself, but we will press a button to start the game. And also, when we will have a game over, the game will stop. We will display this menu that will be displayed when we start the game and also when we get into the game over. And we will finalize by displaying the background image, by playing the different sounds and also displaying the score. And I will finish on that project by sharing with you my different ideas and how to improve this game. Are you ready to start? Let's do it. Let's add a game over state to our game. Now we detect the game over, but we still continue to play. For example, here we display game over in the trace, but we can still continue. We want to stop the game when we get a game over. So we are going to add a new variable that I call the state game over. And as a default, our game is not in game over. But when I will have no collision with the tiles, I will go in game over mode. Self.stateGameOver equal true. Also, I want to print this trace only one time. So I will test if no collisions, okay, and we were not in a game over already. Okay, so this will be executed only one time. Also, I want to stop the game. So if we are in a game over mode, we are going to stop doing a few things in the update function. For example, here we continue to go forward in the game. So we are going to do that if not game over. If we are in game over, we will stop going forward into the game. Also, I want to stop doing the loop because anyway, we don't move into the game anymore. And also, I want to remove the possibility to go on the left and on the right. So all of this block is under this condition. When we are in game over, all of this will be disabled. Let's try it. So you can see I can play. But as soon as I go out of the track, the game is freezed and I can see game over. So it seems it's working well, but I'm going to show you a small case where it's not really working well. It's especially if we put very high speed here, for example 2, and you will see what happened. Here I just start the game. You can see I'm not in a game over, but you can see that the game is freezed already. And if I look, you can see I got a game over. So why does I have a game over while I'm not in a game over condition? This is because when we start our game here, we go in the init and we prepare many things. We initialize all of this, and at the end, we do the clock schedule to call the update function. In fact, Kivy did not finish to initialize everything. He needs to initialize the screen and many other things. So the call to the update function is going to take more time than expected at the beginning. And so for the first calls, we are going to have a big delta time here. Look, if I enable again the trace of the delta time, you can see here in the trace that normally we should have something around 1. And that's mostly the case, except at the beginning. If you look, the first delta time is very high, 29. It's because Kivy was starting, so it took more time than expected. But in our case, what happened? We took that delta time and then we compute our time factor. From the time factor, we used it in the computation of the current offset Y. So we made a big step in one time. And because of this, we were a bit ahead of the computation of the loop. Because in the condition, we check if this current offset y is greater than the spacing y, and in that case, yes, we increment the loop and we remove spacing y. But what happened here is that because of the big value that we put at once, we were far greater than the spacing y, even greater than 2 times or 3 times the spacing y. And so normally we should be in the current y loop of maybe 3 or 4, but we just increment by 1. And so in the computation of the check ship collision, we are going to compare the collision with tiles that are already out of the screen. And that's why we don't get any collision and that we get a game over directly. So the bug is here in this condition. In fact, we should do that as much as we need. And that's why we should replace it with a while current offset is greater than spacing y, we will subtract it and we will increment the loop. Okay, let's start the program again. You could see I got a game over, but it is a real game over this time because it was very quick. So I'm going to comment this trace and I'm going to reduce a bit the speed to 0.8. Okay, so this time everything is working fine. We want to improve our game by adding a menu so that we have a button to start the game and not having this behavior of the game that is starting automatically. Okay, so we will click to start the game and when we will have a menu again to restart the game. The menu widget will be very simple. It's going to be a title, a button, and have an overlay that is going to be a dark overlay. And we are going to use the same menu for the start of the game and for the game over. The difference will be the title and the text of the button that will be modified. So let's just create this menu. We need to create a new Python file that we will call menu. And we will need also to create the KV file menu.kv. Make sure that all the files are here in the same directory. In the menu Python file, I will create my menu widget. And because we are going to use all the screen size, let's make a relative layout. So I don't need to specify manually the size. That would be the case if it was a widget. So I just use a relative layout. So I will also change the main widget and take it from a relative layout. Okay. So now that we have this, we can define the menu widget in our KV file. So menu widget, it's a relative layout, but I still call it widget, that's okay. So what do we have inside? We have a label and we have a button. For the label, I'm going to put a text. For the text, we will do that later. So now I put title, and for the button, I will put OK. Concerning the position, I want to put it in the center of the screen. So I will put center x.5 and center y. I'm not going to put .5 because I want to put the button just below, so I put it just a bit upstairs. So I'm going to put it at 60%, .6. And the button, I will put it a little bit downstairs at .4. Okay, so now let's take this menu widget and let's put it in our galaxy.kv. I put it inside my main widget here. But you will see that if I want to start my program right now, I have an error because I don't know menu widget. I am missing an import statement here. Import menu. Okay. So now you can see the menu is not displayed. And that is because we have the menu.kv file. I need to say to Kivy to take this file into account. So in the main, just before the main widget, I will write builder.load file. And it's going to be menu.kv. Okay, I need to import this Kivy long builder. Let's try it. So you see the menu is appearing and the button is very big. So it's because we did not specify any size for the button. So let's do that. Back to the menu.kv. I'm going to give a size hint to my button and I will put 20% horizontally and 10% vertically. Let's have a look. So you can see I have my title, so the title is in white, so we cannot see it here, but we could show it a little bit. And I have my button. Another thing we want to do is to put a black overlay, almost black overlay, like 80%, so we can still see the game, but have this darkened background when we have the menu. So we can do that in our menu.kv in the canvas. So I'm going to write canvas, and I want to use this as the first instruction. So I will use canvas before. I will use a color that is going to be RGBA. So we have a black color 0, and for the alpha, we are going to use 80%. This color, I will use it with a rectangle, and it will take all the size, self.size. Okay, let's try it. So now you can see that we have our menu with the dark overlay. In the next video, we will add the state to our game to avoid starting the game directly. And we will also use the action on the button to start the game. And when we will have a game over, we will display the menu again. We are going to implement the first part of the menu. So we will start our game only when we click on the OK button. And we will need also to hide the menu in that case. And of course, we will need to show the menu again when we are in game over. So let's add a new state so that the game is not started directly. We will have state game has started. And we are going to put false. So when the game is not started, we are not going to do everything in the update function like we do in the game over. If not game over, we do that and self started, and we should do it only if the game has started. That means if the game has not started, we are not going to do anything here. So if I start again, you can see that this time the game is not starting automatically. Now I need to manage the click on the button. For the button, I can go to my menu and I can add an on press event. And I will create a function on menu button pressed. Okay, we need to put the parentheses here because it's a call. Is it going to be root.onMenuButtonPressed? Not really, because in that case we want to define this function not in the menu widget, but inside the parent, inside the main widget directly. So it's going to be root.parent.onMenuButtonPressed, and I'm going to define this function in the main widget. So I'm going to go totally at the end of the main widget, and I will create this function. I will just put a print button. Okay, so now is it working? If I start, when I click the button, I should see my trace. And you see that the button is not working. I don't see any button trace, and I don't see any lightning on the button. It's like the button doesn't get any touch. And why so? It's because if you look what we did in the main widget, in the user action, we have this function will manage the touch. And if we put a breakpoint here, and if I restart, even when I click on the button, we will go into this function. And the problem that we have here is that this function overrides the default behavior, but will not transmit the touch to the other widget. And this is because we did not call the super. And we need to call super with the type main widget, in our case, self dot and on touchdown and giving the touch. Okay, I'm just going to clean some traces. Okay, so now you will see that we are going to have one issue because we need main widget, you see, but if we import it, user actions will need main widget, but main widget already needs user action. So we have a problem of mutual inclusions. So what we can do here is to give the parent class of the main widget is relative layout. So you see here the import from user actions is here. Okay, so we can take relative layout and put it instead here in the super. And I will import the relative layout. You will see that this time when I start the program, I can click on the button. And when I click on the button, I want to start the game and to hide the menu. So let's do that. Back in the main widget, in my button click, I will start the game. So I put my self state has started to true. But I also need to hide the menu. How can I hide the menu? I can use opacity equals 0. The menu is inside the main widget here, and I need to assign a property to it. So I will use ID menu widget, and I will need to create a new property in the main widget. Okay, I assign this new property, so we will need to define it. menu widget. Okay, so now in the main widget, I go back to the top and I will need to create, I will go here with the other properties, my menu widget, which is an object property. Okay, I need to import object property. So now that I have my menu widget, I can just use it in the click of the button. And I will do self.menuWidget.opacity equals 0. Let's try it. So you can see that if I click, the game is starting, but also you see it moved my player. And okay, after a while, I get the game over. And so we have two issues. First, when I click on the button, also the main widget is taking the click on the window to move on the right or on the left. So we need to change that. And when we have the game over, we need to display the menu again. So why we have this first issue? It's because on the user actions, on touchdown, we should do that only when we are in the right state. And if you remember, we have two states here, game over and game has started. That means we want to do that only when we are not in game over. I'm going to comment that. So if I'm not in game over, I can allow to do the touch actions. And also that the game has started, I can do that. Okay, first thing. Second thing we need to change is from the game over. So, but before that, I want to show you the other thing we need to change is to display the menu again when we have the game over. But I want to show you another issue that we have. So this time you see that I can start and it's not moving. Okay, it's correct. And okay, I will lose. So now I'm in the game over. But you see that if I still click here, even if the menu is not displayed, I still get my button action. And this is going to be a problem on mobile. When we are playing and pressing the screen, it may trigger the action of the button. And why is this? Because we just use opacity on the menu. But the menu is still here and the button is still here, but not visible. So we need to handle that. And what we can do is that in the on-touch buttons, on the on-touch down, so I'm going to copy this function and I'm going to manage that on the menu. And I will say to the menu, so I'm going to delete all of this. I will say that when we touch something on the menu, and if the menu, if self opacity is equal to 0, we are not going to do anything with the touch. So I'm just going to return false. Okay. If the menu is not visible, we ignore the touch. Else we transmit the touch. Okay, let's try that again. Okay, I start here. I click again on the button, but you see that we don't have this button trace. So this is correct. Now I need to manage the game over. When we are in a game over, I want to show the menu again. So I will put opacity to 1. I copy this. And here in the game over state, I'm also going to put my menu back visible. Okay, so let's see. I start. Okay, and I'm going to lose, and then I have the menu again. And the next step we need to implement is to be able to restart the game from the top when we click on the button. And that's what we are going to do next. We would like to be able to reset our game here when we start our game, okay? And when we have a game over, when we click, it's not restarting the game correctly. So we need to develop something to restart from 0, and it's going to be a reset function. So I'm going to add this reset game function. So we need to define it. So we will reset the game to 0, and we will put the right state and remove the menu. Let's define this new function. So I'm going to go just below the init here of the main widget, and I will put def reset game. In reset game, of course, we need to reset the state of the main widget. So it will concern all the variables that we have here. And of course, I will need to put game over to false. Self.gameover equal false. But we will do that at the end of the function, because you remember that clock schedule interval is running. So the fact that we are in game over equal true, our game has not started. It will prevent from executing this part of code. So let's keep this part of code disabled, and we will enable it again at the end by putting game over equal false, because here we will reset different variables. So let's do that. What do we need to reset? Ship coordinates, it's okay because it's going to be recomputed in the update. The ship has been initialized, so we don't touch it. Tile coordinates, we need to reset tile coordinates because we need to start with a straight line. So we want to put self tile coordinates equal an empty list, and we will need to call the prefill tile coordinates. So we will restart from a straight line, and also we will need to generate the tile coordinates at the beginning. Okay, I continue. So tiles, it's okay, it has been initialized, so we keep it. But concerning the speed here, current offset y is our y position, so we need to reset it to go back at the beginning of the game, and current y loop also. And it's going to be the same for the x variables here. We need to start with a speed of 0 and to be in the center of the screen. So let's copy all of this, and I will put 0 for all these variables. Okay, self current y loop, I will remove this one, and I put everything to 0. What else do we have? Horizontal line, okay, it has been initialized, we don't need to touch it. Vertical lines also, and perspective point and menu widget. Okay, so all of this, we don't touch it. So we reset everything, we put back the tiles to 0. And because we put our current y loop to 0 before regenerating, it's going to regenerate coordinates starting at 0. So let's try it. And also you see that because we call these two functions, we can also replace these two lines by reset game. So we can do that. It's not going to change anything, but we can change the code like this. Let's try it. I start the game, I lose, and I can click again, and the game is restarting from the top. Okay, everything is working fine, and let's continue. Let's finalize our menu. First thing we want to do is to put the right title and the right text for the button. So when we will start, we want to display Galaxy for the title and start for the button. And also when we will be in game over, we will change the title by game over and the text button by restart. So how can we do that? If I go back to the menu, we have our label with the default text and the button with the text. So you may say, I can put Galaxy here as a default text and then put an ID on this label and get a property to change the text of my label. But we can do something easier than this. We can directly put a string property here for the title. And that's what we are going to do. I'm going to write menu title, and it's a property we are going to define in the main widget. So it's going to be root.parent.menu title. And we are going to do the same for the button. It's going to be menu button title. So I have to define that in my main widget here. I will say menu title is a string property. So I need to import that. And I will do the same for the menu button title. I can give a default value here. So the default value is going to be Galaxy, and it's going to be start for the button. Also for the title, we want to expand a bit the different letters. So I'm going to put 3 spaces between every letters. Let's try it. So I have Galaxy and start button, but when I'm in game over, I want to display game over and restart. So let's do that. I have to change the value of menu title and menu button title when we get the game over at the end of the update function here. So I'm going to make self.menu title equal game over and self.menu button title equal restart. And for the game over, I'm going to expand the letters, but only by 2 spaces this time because this word is longer. In the middle, I put 4 and 2. Okay. Let's try start and game over, restart. Okay, it's working well. So now let's add some style to our menu. And you will need to use the file I gave you in the resource folder that you can download. You will find 3 folders audio with the different sounds that we will add later. Now we will use the fonts. So it's going to be this font for the title and Eurostyle for the button. And also you will get the background image. So let's copy these 3 folders at the root of your project. You can use a right click on a file and this option reveal in Finder, and then you just copy your 3 folders here. It will appear in the project. Okay, so let's use this font for the title. How can we use a custom font for the label? We use font name, and we need to give the directory, which is fonts / and this name of file, Sackers Gothic std light.ttf. Okay, and also we are going to make bigger letters, so it's going to be a font size, and let's put 60 dp. Okay, let's try it. So that looks nice for the title. Let's style the button. For the button, I'm going to use also these 2 properties. Font size, that we are going to put the half 30. And for the font name, I'm going to use the other font, Eurostyle. Okay, so what do we have this time? We have something that looks great. I want to expand a bit the height of the button and also to position it a bit lower. And we will add some color to this button. So first thing, the size is 10% height. I'm going to give 15%, and I want to display it a bit lower. So I'm going to put it at 30% of the screen. Now I want to add a background color. So I can use a background color, and I prepare the color code for something quite red. So it's going to be 100% red and 30% green, 40% blue. And I put it at 85% opacity. So let's try that. And you can see that my color is not really vivid. It's because it is multiplied by the default button color, which is gray. So to remove this texture, we need to use background normal and to reset the texture. And this time it's going to look nice. Okay, perfect. I can start my game and then I get game over. Everything is good concerning the menu. For this exercise, I'm going to ask you to display the background image, this one, bg1.jpg, in the background of the main widget. So we display the game above all of this. You will need to add this image in the main widget, but you are going to add that in the KV file here. I don't give you more instructions. It's your turn to do the exercise, and then I will show you the solution. How can we display this image? Can we use an image here? Not really, because the image is going to be drawn over the canvas. So we need to display it in the background. And what we can use is a canvas before, and inside we will use a rectangle that will use this file as a texture. So we will use the source property on a rectangle that will take all the window. And because we are in canvas before, it's the first thing we are going to draw on the screen, and we will draw everything else on top. And that's what we want to do. So I'm going to put a rectangle that will take all the space. So it's going to be a size of self.size. And I will use the source image, images/bg1.jpg. Let's try it. You can see that the image is displayed and I can start the game. Okay, everything is correct. Let's continue on the project. Let's display the score in our game. What is the score? And what will be the score in our case? I have decided that the score will be the number of loops defines how long we could go into the path. So it's going to increment and it's going to be finally the value of the score. So where can we display the score? I want to display the score in the game window at the top left, and we are going to add it directly in the main widget. So first we will write some code together, and after you will do an exercise. So I go to the galaxy.kv and I want to add a label. Should I add the score label before the menu widget or after it? It's going to be an important choice, but I'm going to start by putting it before the menu widget label. For the text, I'm just going to try with a placeholder text. It's going to be score 120, for example. And also I'm going to put a style. So for the style, I'm going to copy paste these 2 lines from the button of the menu. And I'm going to paste it here. I'm going to use a font size of 20 and to keep this font name Eurostyle. So what does it make right now if I start it? I cannot see it, but if I start the game, you can see that the score is displayed in the middle of the screen because it takes all the space. So we need to define a size hint, for example, 20% and 20%. Okay, so what do we have? We have something here, but I want to display it at the top left. So I'm going to use a pos hint that will be x0. So that one was implicit, that was already here, but most important is to have the top to 1 totally at the top. So let's see, yes, it's displayed here, so that's correct. And I just want to reduce a bit the margins here, so I will reduce a little bit the size to 18%. Okay, so we have something good, and when we start the game, we will display the score. So it's going to be your exercise. You need to display the real score here, and you will use a property for the text that we will call score txt. Okay, because we are in the main widget, we are going to use root dot directly. We don't use root parent. We needed to use parent from the menu because the parent of the menu is the main widget. But since we are in the main widget directly, it's going to be root score txt. For this exercise, you will define this new property. And in this property, you will need to use the value of the current loop to display the actual score. Do this exercise on your side, and when it's done, I will show you the solution. So what we need to do is to define this score property. I go to the main widget at the top, and here I will define string property because we need to display score and then the value of the score. Score text is going to change when we change the value of the loop. So I go back in the update function here when we increment the current while loop. And we are going to do the score equal to score and then the value of this current while loop. Okay, let's try that. So you can see that at the beginning, I don't see the score because we did not give a default value for the property. Okay, but when I start it, I get 1, 2, 3, 4, 5, and we begin to see the score. And when I have a game over, I can still see the score, but not really well because of the overlay of the menu. And also, if I click on restart, you can see I still see 23 and then 1, 2, 3, 4, 5. So I want to display score 0. And display score 0, we are going to put this line also in the reset function. So it's going to be more clean here. I can put score 0 directly and remove that part, or I can keep that part, and because current while loop is reset to 0, it's going to make the same thing. Okay, let's try it. So this time you can see I see score 0. When I start, I have 0, 1, 2, 3, and when I lose, I have again 0, 1, 2, 3. It's more clean. Now I want to change something. I want to see the score correctly, because here we cannot see it much because of the overlay. How can we solve that? Finally, in the galaxy.kv, we need to display the label on top of the menu and not the opposite. So if I do that this way, I'm going to display the score on top of the menu, so it's always displayed correctly. Okay, that's all for this exercise. Let's play the sounds in our game. You see in the audio folder that we have many wave sounds. So we are going to play these sounds in our game, and at first I'm going to write some code with you, and for the exercise you will trigger the sounds at the right moment. So let's initialize the sounds. We will create a new function, init audio, and we will use the sound loader.load and give the name of the function. Sound loader, you need to import it from Kivy Core Audio Sound Loader. Here we need to give the name of the different files. So I will start with the first one, begin.wave, and I need to provide the directory name. So it's going to be audio/begin.wave. And this sound, we need to save it in a variable, so we can use play or stop on this variable later. So it's going to be a self.sound begin equal this. I will need to define all my different variables here. None. Okay. So I need to copy paste this line for every sound that we have. So we have still 1, 2, 3, 4, 5 other sounds. Okay, and I will copy paste and I will write down the name of the different files. You can see I have a completion here. Game over impact, game over voice, music 1. Why I called it music 1? Because maybe you will want to add some more music in the game later. So I just call it music 1 instead of music. And restart. Okay, so let's rename the variables. Galaxy, game over impact, game over voice, music 1, and restart. And I will copy all of this so I can create the different variables. Equal none. So begin, we have it. Galaxy equal none, impact, voice, music, and restart. Okay, and I will remove the self in the front. Perfect. So now my init audio function, I need to call it from the init of the game. So I will call it at first init audio, okay? And I'm going to add something. We can control the volume of the different sounds. So for the music, sound music 1, we can do dot volume equal 1 is the maximum, it's 100%. For all the voices, like begin, galaxy, and the other ones, we are going to give a volume of 25%. So I will copy paste that. And for the sound galaxy, I'm going to do the same. This is an impact sound, and this one is a voice sound, and restart also. Okay, for the sound of impact, we are going to give 60%. So you can adjust the volume of the different sounds. For me, I will keep these values. Now it's your turn. You have to do an exercise. You need to trigger the different sounds at the right moment. So you will need to call the play function and also sometimes the stop function. The Galaxy voice is called totally at the beginning. When we start the game, it will say Galaxy. And when we will press start, it will say begin. Okay? And it will also start the music. Then later, when you will get a game over, you will play the impact of the sound, and you will also need to stop the music. And you will also play the game over voice. But then the button now is not start, it's restart. So when the user will click on the restart button, you will need to play restart sound. It's your turn to practice, and when it's done, I will show you the solution. So first thing I will do is I will use this begin sound. The begin sound is when we click on the button, on menu button pressed, okay? I can play my sound when I click on the button. Let's try it. Here I press start and it says begin. But I have a problem. In the game over, I'm going to click on the same button and I want to say restart, but it says begin because here we need to test the state. If we are in state game over, then we will play the restart sound. Else, I'm in the first case and I will play sound begin. Let's try that. Okay, begin, game over, begin. So it's not working. And why it's not working? Because you remember that we already reset the state game over in the reset function. So we don't have that information anymore. We need to move this part of code before the reset function. So we have still this state game over. Let's try it. Begin, okay, restart. Okay, that's correct. Now let's start the music. When we click on this button, we are going to start the music. So I'm going to do sound music 1 dot play. Okay. And I'm going to group all the sounds together. So I'm going to play it here. So whether we are in the first case or in the game over, we are going to play the music when we click in the button in every case. Okay, it's working. But in the game over, I want to stop playing the music. So when we get the game over, we have multiple things to do. We need to stop the music stop, but we also need to play some other sounds because we have the sound of impact, game over impact that we are going to play, and we have also the voice sound game over voice that we need to play. So let's see what it gives. And I got a crash. Let's see why. Float object has no attribute play, and we get a problem on that sound game over impact. it says it's a float object. Why? I think I know why. It's when we put the volume. I think I forgot to put volume in front. Let's see. Init audio. And here you see sound game over impact dot volume is equal to 0.6. Okay, let's try again. And then you could hear the music stop. I get the impact sound, and we also hear the game over. That was quite low. And we are going to improve that later. I'm going to show you how to delay the sound. But just to finish the exercise, I need also to play the Galaxy sound at the beginning. So I'm going to take that, and on the init of the game, after init audio, I will put it at the end of the init function. I will play the Galaxy sound. So when I start the game, we can hear Galaxy, then we can start, and then I get the game over. Restart, game over. Okay, so that's all for the exercise, and now I'm going to show you how to improve it a little bit. I want to have the impact sound on the game over immediately, but a few seconds later, like 3 seconds later, I want to play the sound game over. So let's do that. When I get my game over, I'm in the update function here. So when I play game over voice, that's voice sound, I want to delay it. So I'm going to define a new function, play game over voice sound. Okay, so we are going to play the sound, and this function, we need to delay it from here. So I'm going to use clock.schedule once. We want to start it only one time. This function, self.play game over voice sound, okay? And I will specify the delay, for example, 3 seconds. And because this function is used inside the schedule function, I need to give the delta time parameter. So let's try it. So you could hear I got the impact, and then a few seconds later we could hear game over. But in fact we have a small bug. Look, for example, if I restart, you can hear game over while I'm playing the game. And this is because when we get the game over, we trigger that function. That will happen 3 seconds later, okay? So we trigger that, but before it happens, I click quickly on the button here. So I had time to restart the game. And when I'm playing, then after a few seconds, this is going to play. So I will hear game over while I'm playing. So this is clearly a bug. So what we can do is to test here if we are still in a game over state. If self.state game over, then only in that case I will play the game over sound. Let's try it again. And you can hear that this time I didn't hear the game over sound. I will only hear it when I wait. This one. So everything is good for our game.
You have completed the Galaxy project and you have reached the end of this tutorial. Congratulations. You might ask me, so now where do I go from here? What's next? I advise you to practice by doing some personal projects. Let me share with you some ideas. Why not creating a simple game or a simple application like a currency converter or a password generator? Or why not trying to add some features to the Galaxy game? For example, store and display the best score, or manage multiple levels, or increase the speed over time, or add a difficulty choice, easy, medium, hard. And also, we can stay in touch. You can subscribe to my YouTube channel, Code with Jonathan, so that you will know when I post new tutorials. And if you like to learn from me, you can check out my full Python course that includes more than 300 videos and 27 hours of content. Thanks again, and see you soon.